Well, good morning, everyone, and welcome back to European Space Week's plenary session. Ladies and gentlemen, how many of you were here yesterday? I have a personal question. Who has genuinely learned at least one new and valuable thing this week? How many of you? A majority. Let's give a big hand to our organizers. That's very rare that you actually have, at this level, something actually new and useful. And the good news is we have a day of very new and very useful information that is going to be coming from this stage. Ladies and gentlemen, this morning we talk again about sustainability, sustainable space, saving space for future generations. And our first speaker is quite exceptional. We have the professor in computational space physics at the University of Helsinki. And what's really fascinating about her is that, well, after being a researcher at the Earth Observation Program, the Finnish Meteorological Institute, who was also speaking here yesterday, she won, and she's the only person in the world to have won 2 grants from the European Research Council. This is the gold medal in research and in science, and she got it twice in the area of space science. Ladies and gentlemen, it's my great honor and privilege to welcome Professor Minna Palmroth to the stage. Tervetuloa!
Esteemed ladies and gentlemen, space is an emerging megatrend. At this moment, more spacecraft are being launched than ever before. In 2017, more than 350 spacecraft were launched. This is twice as much as the previous record era, which was the Cold War. During the Cold War, the main motivation for the satellites was political. This is because when you control space, you control Earth. Nowadays, more than 70% of the new spacecraft are commercially motivated. Many large companies have announced their plans. May this year, Amazon announced that they have requested permissions for 3,000 satellites. In October, SpaceX announced that on top of the 12,000 permissions they already have, they have sought new permissions for 30,000 new satellites. The bullseye you see on the screen now is not a bullseye on a car windshield. It's a bullseye in an International Space Station window. A debris particle weighing 1 gram has the same momentum as a fist-sized rock hitting a car windshield on a motorway. The consequence of this new commercial space race is that the space is becoming congested by space junk. Since most orbits do not have friction, the space object will stay there basically indefinitely. The total mass of objects in space is already close to 8,000 tons. Even if we stopped launching spacecraft today, the amount of space debris would increase. This is due to a so-called Kessler syndrome, where continual collisions between spacecraft and space objects will decrease the size of the space objects, but increase the amount of them. Each object, whether small or large, will have the same speed as the object where they originated from. This is 7 kilometers per second. A 1 centimeter object is already lethal from the spacecraft point of view. Total number of objects larger than 10 centimeters which can be tracked at this moment is almost 18,000. Smaller objects that cannot be tracked, the number of them is much, much larger. On a polar low Earth orbit at 900 kilometer altitude, the estimated number of 1 centimeter size objects, the lethal objects for spacecraft, is about 9,000. Space debris can be divided roughly into 2 categories: the debris which is already there and the debris which is coming from the new spacecraft launches. Cleaning space from the old debris is a very complicated problem requiring large players like the European Space Agency. Much easier, even though very difficult in practice, is to prevent new debris. There are 2 main aspects in preventing new debris. They both have to do with satellite lifetime and deorbiting technologies. If the satellites would last longer, this would decrease the need to launch so often. If they would be deorbited at the end of their mission, this would deallocate the orbit space for the new other spacecraft coming after them. These 2 means are at the heart of the Finnish Center of Excellence in Research of Sustainable Space. The Center of Excellence in Research of Sustainable Space develops science-based technologies to deorbit and to improve spacecraft radiation tolerance. Space radiation is one aspect of the environmental conditions in space, which is called space weather. Even though many organizations right now are establishing 24/7 services in predicting space weather, we still do not understand the near-Earth environment, how it works physically. I am a space physicist, and I am horrified by the fact that we do not know the environment where we launch our spacecraft. We need new space physics missions and new accurate space modeling tools to understand the physical environment to which we launch our spacecraft. This space physics is the environment which decides whether our spacecraft will be debris sooner rather than later. If we are going to utilize space also in the future, we need to understand and predict the space environment, prevent new debris, and clean the old debris. Solutions to the space debris problem could either be top-down or bottom-up or a combination. A top-down solution would mean binding international and national legislation. As an example, Finland has just made its own space law, which came into force in January last year. Finland's space law is a prime example of a great legislation. It is both driving towards sustainability and at the same time strengthening the foundation of the Finnish space economy. Another example of a top-down approach are different recommendations. For example, many European countries are committed to the European Space Agency recommendation stating that one should try to bring down their spacecraft after 25 years of the completion of the mission. A bottom-up solution to the debris problem would be to develop new technologies which would make the debris a non-issue. Another possibility would be to establish markets to space debris. In January this year, together with the Ministry of Economic Affairs and Employment, the Center of Excellence in Research of Sustainable Space organized the first Sustainable Space Economy workshop. The original idea of the workshop was to think whether there would actually be a business opportunity in space debris, similarly as renewable energy is a business opportunity created by the climate change. We wanted to know what is the economic value of space debris. We gathered a group of experts from space technology, space physics, legislation, regulation, and economy to think about the debris problem from their own perspectives. Some of these people are now in the panel, which comes next. The questions we posed, for example, were to think whether a binding legislation for deorbiting would create markets for deorbiting devices. Another question is whether the space companies are interested in keeping their own investments safe. This would create markets for cleaning the orbits. However, before we were able to answer these questions, we realized that space lacks some basic elements that are needed before the space debris markets can be created. We came up with two suggestions. First, we need to establish a satellite sustainability footprint. Orbit safety depends first and foremost on the ability of the spacecraft to avoid collision and disruption to self and others. Satellite sustainability footprint is a collection of technological factors that are needed to keep the satellite healthy in its physical environment. The other suggestion we came up at the first Sustainable Space Economy workshop is a definition of orbit capacity. While the satellite sustainability footprint depends on the satellite and its ability to stay healthy in different physical conditions, the orbit capacity should be measured in terms of how much one orbit can withstand. The field of economy has a long background in capacity management within what they call common pool of resources. This knowledge could now be utilized in the sustainable utilization of space. Ladies and gentlemen, at the end of this talk, I would like to emphasize that the sustainable future requires every one of us. We need scientists, engineers, lawmakers, policy people, diplomats, just to name a few, to work together on this topic. I would also like to emphasize that Europe has one strength regarding sustainable use of space. We know how to negotiate and agree. These abilities are crucial in deciding what we are going to do to the future of our planet Earth. Thank you very much.
Thank you, Professor Palmroth, for that very thought-provoking presentation. Ladies and gentlemen, our next speaker will be talking about one of the areas of collaboration needed to make sure that we have sustainable space, which is regulation and lawmaking. Interesting to note that of all the ESA countries, the 22 ESA countries, only 12 have a space law, 12, and I believe Finland was the 10th last year to bring in a piece of legislation that was both sustainable and competitive. It was good to hear that this was, in the opinion of Professor Palmroth, a very progressive piece of legislation. Ladies and gentlemen, it gives me great pleasure to invite on stage an international expert on satellite telecommunications and spectrum regulatory affairs. Ladies and gentlemen, please welcome the Vice President of Regulatory Affairs at OneWeb, Ruth Pritchard Kelly.
Thank you very much. I'm honored to be invited here this morning. Give me a moment to wake up my computer so I get my remarks and tell you a little bit about the company I work for, OneWeb, which is one of the large constellations that is being launched in the near future. We've already started, and we are keenly aware of the fact that the media like to call us mega constellations, just to make sure everyone's feeling properly concerned and worried about the millions and millions of pieces of garbage that are being thrown into outer space. As a British company, OneWeb is particularly excited to be part of this program and the EU community at large. And I want to make clear that the commercial interest is to bring affordable and workable internet to everyone everywhere, right? The reason Amazon and SpaceX and the Chinese and OneWeb are interested in this new generation of satellites that are much closer to Earth than traditional geostationaries is you have, in effect, 4G quality internet overnight. That infrastructure will be there for the entire globe, which means the Arctic will have as much capacity as London. London will be underserved, but the Arctic, think what these remote areas will have access to, right? Being remote will no longer mean being disconnected at all. Whether you're on a ship or a plane or a remote rural village in the north of Finland, you will have all the connectivity you need. This is game-changing, the way the mobile phone, the way the internet themselves were 15 or 20 years ago. This is an evolution. OneWeb has already started launching our constellation. We are only going to have about 600 satellites, not 42,000. It will take us about 600 satellites to cover the globe. And once we've done that, we'll keep launching so that we can add capacity, especially in planes over the world where there is more demand, right? And so we're scalable, and we're going about this in a sensible and rational way, as opposed to just launching satellites and seeing if they work, as some other of our competitors are doing. And the first 6, and I note that we launched only 6, and they all work. They all work. We didn't launch demos, we didn't launch possibilities. We launched what we consider to be production satellites, and they all work. And now we are rolling into assembly line production. We have teamed with Airbus, who is helping to make and build our satellites, and they were incredibly excited about the idea of moving into a production assembly line, like cars, like other factories, right? Traditional satellites take about a year. They're built by hand. It's an incredibly specific job. Our satellite factory, just opened in Florida this year, can create a satellite a day. And with 2 assembly lines, we can create 2 satellites a day. And then we plan to launch all 30 of those satellites every month, which means that our launch vehicle suppliers also have to get into a cadence of launching every month. For us, for other people, they might also be launching. They could be launching every week, every day. The space agency with which we are getting licenses, the UK, we have worked with them for almost a year in getting them up to speed with their internal process to issue a license every month, maybe every week. We're not their only licensee. The entire world has got to move into a different speed. Now that space is not just, as Minna said, for politics, but there is commercial future there. There are possibilities that make this a very exciting environment. We expect, by the way, to have our 600 satellites fully launched by the end of 2021 and start commercial service in about 2 years. Before then, because we are going into polar orbit as opposed to equatorial, we will have amazing amounts of capacity over the Arctic by the end of 2020. And we are speaking with the Arctic nations about how do we demonstrate this capability? What kind of tests can we do for your communities? What do they need, whether it's on land or sea and air? This is going to be a new situation. In addition to Airbus, our other investors include Virgin and Qualcomm, SoftBank, an enormous Japanese software company. These are companies with vast experience in both outer space and satellites and telecommunications. So although we are in many respects a startup, in many other respects we have an incredible amount of experience. As to responsible space, OneWeb has actually taken a website, responsible.space. You are welcome to look at it. We are thought leaders on how to go about being a large constellation responsibly. We are not unaware of the issues that SpaceX is facing with the astronomy community because they didn't think about the reflective bottom of their satellites. I mean, that's thoughtless, right? We were talking with the astronomy community before we launched anything. We've been talking to lots of communities before we've launched anything. Our satellites were responsible by design. We thought about it before we launched things into outer space. We chose an orbit, 1,200 kilometers, where we are the only ones. We designed satellites to burn up upon reentry. No one can guarantee complete burning, but we have designed them to the best of today's ability to not be a problem when they are deorbited. We are designing satellites with grappling hooks on the outside of them so that when the future debris removal industry comes to fruition, there'll be something for them to grab and to remove any satellites that we were not able to deorbit on purpose. And furthermore, we are committed to deorbiting within 5 years of the end of our life. We think that the current guideline, 25 years, is not appropriate for today's community. When those guidelines came out 30 years ago, it absolutely seemed an acceptable guideline. We are moving ahead of the regulation. So this is a bottom-up approach, as Minna was talking about. We are taking this upon ourselves to commit to a more rational time to deorbit. We are constantly engaged in dialogues with governments and companies and academia. We publish thought pieces and editorials. We speak at conferences. We are interested in knowing what the community wants from us, what the governments feel they need, so that we can proactively provide it before the top-down approach comes, right? Because an industry doesn't like too much regulation. We like to be responsive and proactive on ourselves to make sure that we are behaving responsibly so the government doesn't have to step in and order us to act responsibly. We are very excited to be part of a current ESA project on active debris removal, and certainly we hope to be active in future such projects. We think that this is necessary. As Minna said, not only should I do no harm, I'm going to leave no trace of myself in space, but as an industry, the space economy must take care of what was left behind. It's a global commons. Yes, I know that when I first started in the field, people used to say, oh, outer space, it's huge. It's outer space. Don't worry about it. Just push those satellites into a graveyard orbit. What's going to happen, right? Well, we know what's going to happen. And furthermore, those of us continuing to launch into low Earth and medium Earth orbits, we need to go through the debris in the even lower orbits, right? So this is the concern with the very small satellites that are being launched. It is a brilliant and incredible opportunity that every engineer in the world can now design and build and launch her own microsatellite. It's amazing. And yet, it is also Shakespeare's pound of flesh argument. You have the right to launch that satellite, but you don't have the right to be debris in the way of my satellite. So how do we struggle with those rights and obligations? I'd also like to point out that the World Economic Forum is creating the world's first space sustainability rating system. Have others heard of this? And OneWeb is actively participating in this. This is the same kind of program that green buildings participate in around the world and other industries where they voluntarily meet a set of standards and then they get rated. Are you a gold LEEDs building? Are you platinum? What level are you on the sustainability rating system? And we think this is another brilliant bottom-up approach for the industry to show that it's aware of our duties to the outer space environment. So that's how OneWeb is proposing to care for the future generations who will also want to share outer space and use it for their own benefits. We are building in the capability to clean up even as we use outer space to connect everyone everywhere. Thank you.
Thank you very much, Ruth, for that wonderful keynote speech. Great to hear that you're going to be connecting the almost 4 million people who live in the Arctic region who do not have connectivity. For myself, I'm a little bit sad because I was kind of happy to be disconnected at sea, but now I could always turn. That's right, I can do that, but I don't have an excuse now. I don't have that excuse now. You're gonna make it impossible for me to have an excuse. But thank you anyway for the great work the great work you're doing. Ladies and gentlemen, it's our panel time, and we have a great moderator for this panel coming up with the panelists on stage very soon. She's a chief specialist at the Ministry of Economic Affairs and Employment. She's also working on a very inspiring PhD thesis. I find the title of her PhD thesis quite inspiring. It's Europe in the Final Frontier: the legal implications of EU outer space activities in the context of cyber attacks and space objects. Who better to moderate our next session, ladies and gentlemen, on sustainability of space than Chief Specialist Jenni Tapio and her wonderful panelists. Welcome, all of you. Yeah.
Good morning. Happy to be here with you. Good morning to the STAR panel and good morning to the audience. We are now starting the panel on sustainability, which is something that you've already so far heard is the very key priority of our EU Council presidency. And it's my absolute pleasure to be here. Thank you, Andrei, for those kind words and introductions. It's very rare that we have the space family here in Finland. And as you made your way to come here, you probably noted that we are pretty far away. But we are not in isolation, nor do we want to be in isolation. And that's why we value cooperation and talking. And that's why we are here to talk with the exceptional experts on how to use space in a sustainable way and how that could benefit our blue planet. So we need to talk, and that's what we are here to do. So let's talk. Natalia, a dear friend and a colleague who's very experienced in the space diplomacy area and is the incoming chair of the Scientific and Technical Subcommittee of the UN Committee on Space Affairs, so the United Nations Committee on Peaceful Uses of Outer Space gathering in Vienna. So if I could just start by asking you, what is your personal fascination in space? Why do you think that it's important to talk about these topics? Oh, sorry.
Hello, yes. So, good morning everyone, and thank you, Jenni, for the kind introduction. Well, fascination in space, I think it comes in the dreams of pretty much every child or every one of us looking at the stars, and now knowing that men, yes, for now men only, but maybe soon women, have gone up on the moon and soon maybe further. But space, I think, is not to be forgotten, is a tremendous instrument for us to improve sustainability on Earth. All the technologies, the data we receive from satellites, all the experience we gather by going up to the moon and further, it's very useful for our daily life on Earth. I'll stop here, thank you.
Excellent. I think that really highlights what was already said yesterday, that space is not only for exploration, but it's actually something what is very near to us and something that is very practical and something very usable. So thank you for that comment. So Roope, if I may to pose the same question to you, and as well, why do you think that sustainability is an important topic to talk about?
Well, I guess the first question was, why do I think about space? Well, I started building space stations when I was playing in the sandpit when I was 5, and I was looking at the stars thinking, that's quite cool. And since then, I figured out that we don't have any astronauts in Finland, so that carries out, unless I make my own rocket engines, so then we started doing that now. In terms of sustainability, it's pretty clear, if you make a mess, you clean yourself up. In a small country with few people, there's nobody else to do it. And you have to think of it this way. We have the forests here, we have the commons. but it's up to us to keep them that way. There is no janitor around. And this, of course, applies to space as well.
Thank you very much. And just to note that you are the CEO of a startup company who is really looking into making space more sustainable by providing propulsion technologies. So it's very good to hear as well that you have such a background in thinking about space already for a long time.
Well, in addition to the propulsion, we also make brakes to take the satellites down. I don't know if you can call that propulsion. It's unpropulsion.
Very good. Thank you. And so, Holger, you are the head of space safety program at ESA. So why do you think it was important for you to make all that way from Darmstadt to come here to Helsinki to talk about this topic today?
Thank you very much, Jenny, and good morning. And thanks for inviting me into a panel with so many distinguished colleagues. So indeed, my fascination for space comes from the fact that for hundreds and thousands of years, exploration went in 2 dimensions. And since 60 years, humans as a species managed to explore in the 3rd dimension, visit other bodies outside. This is so abstract and absurd and fascinating when you think about it. Now, ESA has been traditionally working on space sustainability for a long time, and we think space is there to be used. I sometimes hear very radical positions, in particular of students, let's better not use space at all, and that's actually not my paradigm. So space is there to be used and to be explored by the taxpayer missions of the past and by the paradigm change we are seeing there today. If you look at your smartphone today, 40% of all applications rely on services from space, navigation, telephone, weather forecast, and the future, maybe even the internet itself, as we heard before. So we need to preserve that. And when we speak about space, we actually mean a very tiny layer. That's where the problem sits, just a band of a few 100-kilometer altitudes, because, as previous speakers said, we are not using the vast regions of space, we are using just the small portions. And ESA has set out an ambitious program, the space safety program, which will look into all domains of the space safety and space debris problem, and maybe later we can come back to that. Yeah.
Yes, definitely, and thank you, Holger. And I think it's also good to hear that sustainability is not only achieved by not using space, but we should use space in such a way that it is actually sustainable. So thank you for that comment, and we will definitely come back to the space safety program just approved at the ministerial. So Ian, welcome. You are the Director of Private Sector Programs at Secure World Foundation. So did you also want to become an astronaut? In the US, it's actually a possibility today. And how is an NGO, what are you doing to further the issues relating to sustainable uses of outer space?
So thank you, Jenny, for the introduction and for allowing us to join this panel. It's a pleasure to be here, traveling from the U.S. to participate in this event as well. So my path to the space community did not come through interest in being an astronaut. My path to the space community came originally through biochemistry and political science, and eventually getting interested in science policy, where I was first exposed to space and very quickly drawn to the inherent international aspect of this sector and of this area of economic activity. I don't think that there's any other area of human activity that is inherently international as space activities are. Anything large in terms of a civil space project, a scientific space project, or even today a commercial space project requires international collaboration, international discussion, international interactions. Sitting here at the European Space Week, international collaboration, international discussion is something that's very much a day-to-day part of what all of you are engaged in regularly, and that's a very key aspect of what drew me to the space sector. Those scientific benefits, those civil benefits, those commercial benefits, my organization, Secure World Foundation, our interest in space sustainability is in continuing to provide for a stable orbital environment that allows those benefits to accrue and allows society to use, access, and benefit from space systems and space technology. And so that's where our interest in sustainability comes from. Much of what we do, and I'm sure we'll get into this during the discussion, is about collaborative dialogue, looking at challenges, looking at opportunities, and helping the community at large to develop solutions to those challenges. So come back to that.
Yeah, excellent. Thank you, Ian. And I think it's really valuable to hear that how it's all the actors doing work together, and that is the way how we can actually achieve the goals by talking to one another and coordinating and sharing information. So thank you for that remark. So Pascal, you are the chair of the EU consortium of the member states on space surveillance and tracking. Welcome to Helsinki. And also it would be very nice to hear from you. How did you come fascinated about space? And what do you think that sustainability means today for your activities?
Thank you very much, Yanni, and good morning, everybody. I would like also to thank the organizers of this wonderful European Space Week in Helsinki for their kind invitation and for giving me the possibility to intervene in this panel. Why space? I don't remember very well. I'm in this business for the last 20 years, 15 years. I think at the beginning I used to be an oceanographer with a PhD in this domain, and I think that I have two passions, ocean and space, and at that time I think those are two domains of international cooperation, two domains with plenty of challenges, without frontiers, without borders. And so I've chosen space because it's even more challenging today. We are facing very challenging, fast-changing space environment where risk and threats are both increasing, where we need to take into account the duality of the space domain, the duality of space situational awareness, space surveillance and tracking in Europe. And so that's why I believe that the question of SSA and SST is of utmost importance for space sustainability. I think this is where we are. I think that this is SSA and SST is a global and shared responsibility, and we need to all act together to improve the situation right now. Thank you.
Thank you very much, and I think that's what we already heard yesterday, that there's a lot in common with oceans and space, and indeed even in the discussion on space resources, we always refer to the question on the oceans, so those are very much connected. Just to follow up, I'm not sure if everyone here is so knowledgeable about what do you do in the consortium and what actually all the abbreviations that we love here in the space sector, SSA, SST. So how would you, in layman's word, describe what is it that you do?
Thank you, Yanni. So yes, I have the privilege to chair a consortium of 8 member states of the European Union: France, Germany, Italy, Spain, UK, Poland, Portugal, and Romania. This is a particular setup of a group of member states which own, controls, and operate their national sensors. So we put all those sensors together and we share data through a European database. And this is a huge achievement at European level, to have this European database and tomorrow European catalog. I think this is unique today in the world. I do not see any other regional cooperation in the world where you have some member states, some states, nations sharing data on a regular basis, thousands of measurements every day through a database. And this is what we do currently in Europe. Then we provide top-class collision avoidance services, fragmentation and reentry as well. Those are added value services. And I used to say that in French we say haute couture services. What we do is we activate our network of sensors to track secondary objects in case of risky conjunctions, and then we refine the orbit of the secondary object and we provide recommendation to spacecraft operators. And for the moment today, we protect 131 satellites of the European Union and its member states from risk of collision. with an operational service 24/7. In all orbit regimes, LEO, MEO, and GEO, those satellites are civil, military, commercial. So it's a huge effort at the European level where we operate a network of sensors. We build a database, a European database, and soon a European catalog, and we provide operational services. And of course, our political objective at the end would be to build a European autonomy by improving the performance of our European sensors. And this is where we can place Europe as a robust and reliable partner in this domain, because again, this is a domain where we need to share the responsibility, and Europe can play an important role by improving its strategic autonomy in space surveillance.
Yes, thank you for that explanation. I think it's always good to bring a bit of more words to such abbreviations to better understand the topics. But so, Holger, if just to follow up on that, so what is ESA currently doing to make space more safe and sustainable, not only for the present generation, but also for the future generations?
Thanks very much for that opportunity. And indeed, ESA is looking into an ambitious space safety program, which has addresses space debris from all sides. So we will attack it from all sides. First of all, Mr. Fauché nicely explained space surveillance is where it starts. So space surveillance is a very important factor. Technology that we can use to support these member states making the information they are providing, and which we are using ourselves from that consortium. ESA in the end is also an operator of 20 spacecrafts, and we are depending on that information, and we are very grateful for that information to come. And we can make it even more accurate by looking into supporting the member states with technology, for example, on laser that provides even better information, more accurate, helping the operator to bring down false alerts and the many alerts they're receiving in view of conjunction. That is number one. Number two is we also need to understand the environment we are living in. We believe we have 30,000 objects above 10 centimeters size in space. Out of them, only 2,000 are the ones we want to have, meaning living spacecraft providing a service. Above 1 centimeter, the estimate is about 900,000 objects. And above 1 millimeter size, the estimate is on the order of 100 million. And if you remember the impact chip, the picture you saw from the space station, that's caused by 1 millimeter. So that's still meaningful energy contained in these kind of objects. We don't even know precisely how many are there out there. It could be 100 million, it could also be tenfold. The uncertainties are extremely large. We need to go up and place a sensor into space and measure the impacts and also try to sense these small objects which you can't see from ground. This is a very important cornerstone in the program. Then, we heard already from Professor Palmroth what needs to be done. We need to mitigate and prevent future debris. The problem we are having in space will stay, but we are working hard to not make it worse. It's quite comparable to the climate situation. We will not change the temperature increase that we have already caused. We are working hard to not even make it worse for future generations, and that's quite similar here. We need to prevent a further degradation, and that means mitigation, disposing objects to low orbits from where they disappear from space within 25 years or even less, making sure they don't break up. So are we successful in that? Not really. You can quite nicely, by the way, using surveillance data, you can quite nicely see how well we actually perform, because you can see whether the various actors actually do that. And it turns out only 50% of them today manage to do that. Of course, this is old technology, but this is where we need to help. And it's not always bad intent. I'm convinced it's also lack of technology, because it's like driving your car for 5 years out of the garage to work and back, a very short distance. And then after 10 years of lifetime, you would have to do a trip around the world. That's comparable to operating a spacecraft day by day and then disposing it after 10 years. The likelihood that it fails exactly at this very long trip is very high. And this can be overcome by putting more redundancy on board, putting extra devices on board that are independent. And that's what we want to stimulate also in the program by providing these technologies to European actors. And then our flagship is also to remove a piece of space debris. So we will actually go together with a commercial company based in Switzerland to fund that with a market orientation right from the start in view of demonstrating that you actually can do it, that an object that is in space already while we talk and is not in function can be removed. Why do we want to do it? Do we believe that we need to do it for all the 30,000 objects? No. But we believe that regulators who are perhaps hesitating to enhance their space law with more mandating or demanding options like making active removal mandatory are waiting for this to be demonstrated before they dare to make that steps. And we want to break that cycle with that mission. So by 25, this object will go down. And finally, the environment will change not only by having more objects, but by also having more operated objects. So in other words, you have many more actors in space running their satellites. And that means that encounters between two active objects, which are rare today, because normally you meet a piece of space debris, in the future that will be more or less normal. And if you compare to how this is managed in the air traffic world, where you have flight rules, flight levels, protocols, standards, this is all missing in space at all. We are coordinating by phone and by email. So this needs to change as well, and we would like to bring about the technology for that. And now I talked too long, sorry.
No, that was just perfect. Thank you so much. But just to come back, you mentioned the 25-year rule, which was also mentioned by Ruth and Minna in their inspirational speeches. Would you say that that rule is still adequate and usable for today's activities?
Yeah. I think that rule is still not too bad. I mean, it's always good to go for even shorter lifetime. I think our problem is not that 25 years are too long or too short. Our problem is that today nobody adheres to even 25 years, right? It's like the speed limit on the motorway. If you have a 100 kilometers in an hour speed limit, and everybody drives 200 kilometers in an hour, it doesn't help if you put the limit to 90 kilometers in an hour. There's a fundamental problem that we need to solve first, and that is to make everybody better in adhering to at least what we have today. And then I think later we can come back how future guidelines might have to look like. And if we come back to that, I have to add another 2 cents maybe.
Thank you. And I think that was exactly something also already mentioned, that once the rules are not binding, it's voluntary to adhere to such guidelines. So just that these guidelines are now the way forward, and this is the way how we do international space governance. And there was a recent heralded milestone moment at the UN COPUOS. So yes, Natalia, it would be very good to hear as well that how do we bring that work done at the UN COPUOS level, so the very multilateral international level, how do we bring that work down to the level where space missions are actually carried out, so be that regional or national levels, and that work, so that those opinions are also heard at the UN level?
Yeah, thanks very much. Yes, indeed. I think it's a very important question with respect to the governance of space activities. How do you connect space diplomacy, what is done at the work at the level of discussion among states, to the operators, to the entities actually launching and operating satellites, and vice versa, as you mentioned. How do we, I mean, member states of the UN or of the UN Committee on the Peaceful Use of Space, how do we better integrate in in what we elaborate among states coming from the operators, so those really conducting the space missions. So this is indeed a challenge, and well, states have to do their homework. They have to connect with their entities under their jurisdiction which conduct space activities. They have to set the framework for them to apply those guidelines which are developed at international level. And they also it's also in their responsibility to consult those entities, private sectors and others conducting space activities. So there is the first element of reply is that states need to do their homework and liaise with the entities under their jurisdiction. That's the first thing. And then I still believe that at the multilateral level, so this UN committee, we could still improve the way we collect the inputs from the private sector, from NGOs, from also the academic sector who is also operating satellites. So this has been a reflection, sort of permanent reflection in the last years within the committee. How do we better collect and integrate the inputs from those actors which are not state actors? But I think we have started to find solutions by organizing workshops where we do invite such actors, non-state actors, and apart from the very formal sessions, we also have different kind of events where those actors are invited. And in the end, again, member states can invite in their delegations, in their national official delegations, they can invite actors from those other sectors. Thank you.
Yes, thank you very much, and I think that was a very good outline about what is it that we do, but also what we are aiming to do, and somehow better receive the comments from the actors, but also to make known what is the work done at the UN level. And Roope, I would like to ask you next, because also someone having come from the private sector to join the UN for the first time, it felt something quite far away, and it felt something like very not easy access, because even the language used at the UN level is not the same as we use here in all the other activities. So how do you feel that there is access for especially startups to reach the UN level, and as well, what could be done at the UN level or other multilateral forums to incentivize startups to be a part of this activity?
Well, firstly, I guess you're asking the wrong guy. I was brought up in a UN family, so I know the jargon very well. All my friends when I was a child spoke UN. But for startups, you have to remember that when you talk about guidelines, they are very difficult to implement in engineering terms. Engineers are simple-minded people, like myself. We need actionable items, specifications. No, what do I need to do? 25 years is really good because we can derive numbers and mechanisms out of that. But keep space clean is not actionable. It's difficult to say, okay, what is a machine that cleans up space? Of course, we don't have those technologies either. That's one of the reasons I started making rocket engines is if you can't move a satellite, you certainly can't deorbit it or avoid the collisions. So you do that. But the other question is that if you get to this stage, then the next question is, can we make it affordable enough that it's worthwhile doing? A startup can afford maybe €500,000 for a satellite. If the deorbit system costs 3, they're not going to do it. They just can't. So we have to balance the ability to do it with the requirements, and that's why maybe the legislation has to move a little slow. But at the same time, we need to make clear what are the actionable items or the specifications that can be derived from that legislation that's coming in the future. Because that now is the time the startups, the companies, OneWeb, us, are creating technologies to solve those problems. If the legislation is something else and requires other problems to be solved, then our work is in vain. So we need to have this discussion and discourse about what is needed, what are maybe the more concrete ways to approach it, create the corpus of ideas, and then there's plenty of companies who can start implementing.
Very good, and good that you brought money into the discussion. Cost is always an issue, of course. And Ian, have you encountered or discussed with, you are talking with the businesses all the time, so what is your thinking, who should bear the costs?
Yeah, so that's a fundamental and excellent question. So I'm gonna come back to the answer in kind of a roundabout way, if you don't mind. Bear with me for a second. So listen to my fellow panelists talk here. I think what we're dealing with is a change in the space sector to a more complex orbital environment, right? More satellites, many different types of applications, many new actors, and a diversity of actors. And we're struggling to figure out what is sustainable behavior, what is responsible behavior, how do we incentivize that, how do we pay for it, how do we develop that? And so I think in wrestling that question, there are three things we need to look at. We need to define what responsible and safe and sustainable behavior is. And we have initiatives like the long-term sustainability guidelines at the multilateral level, we have national initiatives, and we have industry initiatives to do that. So Secure World is involved in several of these things. One of them is the Space Safety Coalition. OneWeb's a member. Holger, you've been involved in the preliminary conversations about that. There's another effort called the Consortium for Execution of Rendezvous and Servicing Operations, which Secure World is a facilitator for, that's looking at developing best practice for on-orbit servicing. So these are initiatives where industry is coming together to define their own set of responsible practices, and that ties back to multilateral initiatives. Second thing is I think we need to define figure out how to measure and track performance to these initiatives. So activities like the World Economic Forum Space Sustainability Rating that was mentioned earlier, that's a key effort to do that. We have other efforts to do that. And then we need to figure out how to encourage and incentivize actors to operate to these guidelines and to these best practices. And that's where the money question comes in. So how do we pay for debris removal? There are companies that are looking at that as a business model. I think there are some questions around that, but I think we're beginning to get an answer as some of the large constellations come into play. That changes kind of the economics of how low Earth orbit can be valued, and that might create an economic incentive for some of the debris removal activities. I think we need to look at the role of the investor sector. The investor sector can both think about how investing in activities or actors that act responsibly benefits the business environment, and the investor sector can think about how the impact and the social impact of investment contributes to responsible behavior. I think we also there's conversations around what the insurance community can do. So all of this comes into the question of how we pay for it and how we incentivize it. So, thank you.
Yes, very good, thank you. I think that's the cost topic would be something very much that we could continue with. So Pascal, I mean, do you have interactions with companies, and how is your operations working with the private sector?
Yes, thank you, Yanni, for the question. Of course, our setup is a group of member states, but we are subcontracting a lot to our private companies. We use also commercial data, of course, as well as scientific and military sources data. So yes, of course, our industry is involved, and we are also preparing the future. We are upgrading our sensors. We are improving the level of performance of our surveillance and tracking sensors in Europe, and we will, of course, ask our industry to help us a lot. So they are involved in the process, and they will be more and more involved in the future, for sure. Maybe coming back to United Nations guidelines, and I agree with you. Some guidelines, they are top-level guidelines, and it's in terms of implementation, this is what we are doing in Europe. We are implementing some of those guidelines. When we provide collision avoidance services, there's one guideline relating to that topic. So We have 21 guidelines today adopted, and this is a tremendous result. This is the result of 8 years of work. It's a long process. I know this process very well because I was deeply involved as a French delegate in this process. It's the result of a very good dialogue between the nations. It's the result of a compromise that took some time, and maybe you may know that Vienna is today maybe the only place where we still can discuss this kind of subjects, space sustainability. Other places are today blocked. This is where we are. So in terms of implementation, it has been decided to set up a new working group, LTS. This is the next generation on 2.0. And I think one of the objectives of this working group should be to focus on implementation of those 21 guidelines and maybe help the private sector, NGOs, states, and emerging. I would mean all those states who would like to implement those guidelines, help them to better understand and provide recommendation, even revising some, updating or clarify some of those guidelines for an immediate implementation. We need absolutely to implement those guidelines. And some of them are in the real life, operational, and this is what we do in Europe. We provide operational services. We rely on our industry, private sector, academy. So it's very, very important to translate those guidelines into practical and immediate action in space.
Yes, and you brought up a very important issue, which was also a bit mentioned before, that definitions, common understanding, which is something that we have to reach, and these non-legally binding guidelines developed at the UN level, of course, are a bit policy documents which need to be interpreted and understood, and hopefully in a very same way by the member states. And finally, they also need to be implemented to make them effective here for the companies and for the states. But also, in addition to the implementation, there is the other side of it, so the further work. So Ian, would you have an idea, for example, what sort of topics should be addressed in the further work of that working group just mentioned?
Yeah, so specifically the long-term sustainability guidelines and the next phase of that. And I think, Pascal, you mentioned the expert group structure, and I think if we track back to the original process that led to the first 21 guidelines, those originated with expert groups that were set up at the UN, and that did allow non-state actors to participate in the beginning of that process, and then it went into the formal process before. So I think as the working group begins to look at LTS 2.0, I may steal that from you. I think it's important to consider the expert group structure again and bringing back the private sector and civil society participation in that. So in terms of topics that we may look at, if we went back, there were a number of guidelines, a number of discussions that some topics that I think the multilateral community felt were not quite ready in this first stage, and I think we may go back to those. Rendezvous and proximity operations, I think, is an area where we may consider there's certainly industry activity going on that's looking at best practice and industry guidelines that may feed into a conversation at the multilateral level around that. I think the question of post-mission disposal practices and building on some of the existing guidelines that begin to look at that may be something that we could expand upon there as well. Trying to think what else. Some discussion, I think this goes beyond the guidelines, but the question of the 25-year quote-unquote rule, which is really a guideline, and whether that is sufficient. I mean, Holger, I think you told us that you think it is, or at least is something that we can continue to work with. I may question that. I think of different domains. We may need to begin to think more specifically about shorter durations, and I think we're looking at industry actors that are already thinking about shorter durations, and if we can encourage that, it helps people think about their operation concepts from the get-go. So I think that's an area where there's future conversation around, again, outside of the LTS process probably for that one, but so there's a few that I'd suggest there.
Yes, very good. And it seems that it's not a paper taste with the UN topic, so Holger, please
Yeah.
comment.
I actually wanted to comment on something else, but I would like now to pick up on that. It's true. I'm fully with you that 25 years are too long. I'm just saying that we have a more fundamental problem underneath, and that is that people have difficulties in following, not because of bad intent, but because of a practical problem that every space operator has. That an aging space system of 10 years will have to do a tremendous effort at the end of its life to get down, several hundred kilometers in many cases, and that's a technical challenge that we need to support with technical means, and that's I think where I see the role for an agency like ESA to do that support. And yes, when we think about the future of guidelines, I think we need to also rethink more fundamentally, because so far the guidelines address each object specifically. We say, get your object down in 25 years, make sure it doesn't break up, and do all this with a probability of 90%. And here's already the caveat. 90%, that's what most standards say, mean that with 10% chance, your spacecraft can fail and will stay up. Now, that works with the number of spacecraft we are having right now. Let it be 100 spacecraft, 10 may fail, and the guidelines are fulfilled, right? Let it be 1,000, then 100 may fail and stay in space, and the guidelines are still fulfilled. So, and 10 or 100 makes a difference. So in other words, the guidelines we're having now have no control about how many objects we are leaving behind. And therefore, I would like to come back to what Professor Palmroth said in her talk. We need perhaps to start thinking top-down and understand space as something which has a limited capacity, which somehow needs to be, I wouldn't say organized, but if you compare it to other problems which have similar structure, like for example the use of frequency bands, that is also a limited capacity, and there's a UN approach to organize it. That doesn't mean that the UN says who gets what, but that it is a consultative process among the players that would like to use space to understand how much use, how much share of the space do you need for that mission. And in order to understand how much share of space you use, you need to have to undergo a technical assessment, which we call the environment index or capacity. So we need to understand the consumption of space of the mission. And when we understand that, we can top-down allocate, and of course it needs to be done in a consensus, in a similar way, like we allocate frequencies perhaps one day. And how can you fit more objects into that capacity? Because what we want to do is, of course, to do as many as possible. That's what I said in the beginning. We want space flight. So how do we get as many as possible in there? And there we have a few parameters to play. One is the reliability, 90%. You can fit more if that is 95%, in particular for objects that are very critical for the environment. And you can fit more if the orbital lifetime is not 25 years, or about 5 years instead. But the choice between that, I think, doesn't need to be necessarily regulated by guidelines. It could be an engineering choice if we just allocate how much space may be consumed by a mission. It's very theoretical and very abstract at the moment, but I'm convinced we need to think along these lines in the future.
Thank you, Holger, for that future-looking comment as well. Roope, you wanted to react on that.
Yeah, actually following up from this, in actualizing technical things, how do we bring the policy down? It seems that when you get enough players in the loop, we need to start making rules of engagement. In technical side, that would be standardization. So I would even say that we are in the verge where we have to start standardizing. Otherwise, our technical devices that need to interact in space or on Earth, they will not match in each other. I think Ruth is already in that game with the telecommunication standards. The phones will not work with your satellites if you don't have some kind of a specification or a standard how it works. But in terms of, for instance, taking satellites down, when we, for instance, send a space janitor satellite to pick up something, it would be nice to know what kind of a grabbing point there is and that could be standardized. And there are small things that we need to start doing there. We probably need to also start looking at what is the standardization venue where we can come together and discuss, and what are those. And that would help the engineering community to understand and how to actually do this. Standardization is actually a level between legislation and the bottom-up approach, so it's maybe the next step in development.
And bringing the standardization in the discussion is very valuable, and exactly also highlighting the differences with all these levels of guidelines, standards, the policy documents, and the engineering practices, and all these combined in the way of bringing space more sustainable. But Natalia, if you could just maybe react on that, the UN side, for example, on those further topics that should be addressed in the working group. So, for example, issues relating to active space debris removal, already mentioned in this discussion, are currently not within, as such, the 21 guidelines.
Yes, thank you very much indeed. Maybe before I go into that, I mean, and it is related, I'd like to react to what Holger has said, which I think is a very valuable point. We have, for the allocation of frequency, we have a UN international intergovernmental organizations dealing with that at technical level. And for space we have known, actually. But now when we look at the projects for, is it mega constellation, is it large constellations? I mean, the projects for many satellites, and often when we speak of a constellation, they will use the same area of near space, so the same kind of orbits. And then for such kind of areas, we may need to have a stronger coordinations among states, and not only at regional levels. So I really want to emphasize here the need for work at global level, because on orbits you have satellites from all countries, or you may have satellites from all countries over the world, and we know that there are many more countries now looking at having space activities, at launching satellites, etc. So actors are becoming more numerous, but also more diverse, with the private sectors, but with also new state actors. So we really have to have a look to address all those issues at global level. That's my firm conviction. And now how to further the work. We have indeed these 21 guidelines on the long-term sustainability of space activities, which were adopted by the United Nations this year. And at the same time, we decided to continue the work within a new working group. It was mentioned already. And suddenly, the implementation of the 21 adopted guidelines is an essential step. And it is essential to work together at global level to better understand what those guidelines mean indeed. Because there are some are very top-down, others have technical elements, and it is also important that we sort of coordinate the way we implement them throughout the world. But at the same time, we are facing space, the use of space is facing new challenges. We've heard about the debris, there are other kind of threats, and one element which is very important is also to build confidence among states. As Pascal was saying, Vienna, in our jargon, Vienna is the only place which is working with respect to space governance. But that is when when we think there are other places like Geneva with the Conference on Disarmament, and New York with the General Assembly, where space is also addressed, but with a more security or arms control aspect. And the discussions within the Conference on Disarmament are indeed blocked, have been blocked for 20 years. So that's why we say Vienna is working. That's in our jargon. But so it is very important that we use this platform we have in Vienna, this committee, this UN Committee on Space, which is working and which provides to all states a platform to discuss such issues as debris, as what we do and how do we agree. When we think about active debris removal or on-orbit servicing, those close proximity operations, they have or they may be used in a hostile way. So we need to be transparent how we do such kind of activities. We need to communicate to other states what is the intention, why do we approximate to another satellite. And we also need at the technical level to be very careful because as I understand it, those kind of activities are very difficult on the technical point of view and the probability of accident is not low. So we need to coordinate and we need to communicate better. Thank you.
Just Pascal, you wanted to react as well. You've been part of that work at the UN too.
Yes, and I like very much your idea of being concrete, pragmatic, and developing standards. I think this is what our private sector needs. This is what our operators needs to implement those guidelines. I would like maybe to share some numbers to understand where we are. I read recently the last NASA Space Debris Quarterly News. It's published, I think, every 3 months. And we have a satellite box score. It's very interesting. When you look at those box score, you see that there are currently 17,457 space objects, public objects, cataloged by the US Space Surveillance Network, belonging to 3 nations: United States, Russian Federation, and China. And it corresponds to 88% of the total population. If you add to this object all the military satellites which are not public in this catalog, you have much more than 95% of the objects up there, catalog objects up there, above 10 centimeters, which belong to those 3 nations. So when it comes to the question of global governance, regulation, it means that at least you need to have those 3 nations around the table to discuss that topic. This is the current situation, and this is where we are. So I like the idea of being pragmatic. I think today we are in a situation where all the nations entered together in an era of more transparency, building measures of transparency and confidence building, guidelines for implementations by the nations. It's an era of where we share more information, where we need to better coordinate in a pragmatic way if possible. And this is what we do again in Europe. And I think we need to focus on our strategic autonomy in Europe to build and develop our capabilities to reach this strategic autonomy in Europe, to be a reliable partner, because it's a global problem, and Europe should be a key player in this domain.
And definitely, it's very good that you point out that it's not only the private actors that need to be getting on the same table to talk with everyone, but it's also to ensure that it's not only a national or regional effort, but we all states need to see eye to eye on this topic. And just to come back exactly on that standardization topic, so Ian, you think that standardization could be the way forward, but who should make these standards?
A way forward. I don't know that it's the way forward. I think we need multiple streams. But I'm glad to have heard standardization mentioned a couple of times in this panel, because I think it is, Vienna's working, but I think standards is also a governance structure that is working today, and it's one that we can leverage further, and is one that relates back to the multilateral processes. So where was I going? So standards, standards are an accepted and well-known mode of operations within industry. Industry knows how to develop standards, participate in the standards development process, and then take those standards and use them in operations, right? So that's something that industry is used to doing, and something that we can think about leveraging further in the space sector. I want to specifically kind of put an advertisement or a promotion in for the effort that we're involved in. I've mentioned it before. It's called the Consortium for Execution of Rendezvous and Servicing Operations, or CONFERS. It's focused on active debris removal, satellite servicing, rendezvous and proximity operations. We have 35 member companies from the US, from Europe, from Japan, from Canada, and I'm missing one other country, but you get the idea. It's a global activity, as most of the major operations or major operators that are doing rendezvous and proximity related operations. That group has published in July of last year and recommended in June of last year an initial standard that is now going through the International Standards Organization, or ISO, process to become a formal standard. So we've taken an industry-developed set of principles, referred them to an international organization that is now taking that forward, and it's taking that forward in a context that is driven by states and their appointed experts. So we as an industry group have recommended our set of principles that we think are initial best practice for rendezvous and servicing operations, and that's being taken forward in a formal process. And you can go to the CONFERS website and you can find our recommended principles, and that's there. They focus on things like transparency. They focus things on like third-party risk and mitigating as these operations are done, because as Natalia pointed out, there are some complexities there. There are some risks there, and there are some issues about what's a civil commercial activity versus what's a national security or potentially less civil activity. And we need to be clear about where those boundaries are. So the standards process can contribute to that. And I think it's a model that we can look at for other areas of responsible space practice. So we know that the IADC space debris guidelines are reflected in an ISO standard, and they are used within industry. So that's one way that a guideline has become something that's a little more, it's not hard law, but it's a little more concrete, a little more implementable. So it's a model that I think we need to think further about.
And thank you. And it's really important that the requirements reflected through standards are exactly one of the ways forward. And then, as cost was already mentioned before, of course, if would one option be to reflect these in the customer requirements in the contracting? And of course, here I'm looking at Holger, ESA being very active with the European space industry and buying services. Is that something that you reflect in your requirements towards the companies?
Yeah, thanks, Jenny. Yes, all our spacecraft are developed by private industry in the end. So, but ESA is not a country. So still we have put up our own law, if you will, and that law, or we call it administration note, has a character of a binding law for our missions. And our Director General is insisting very strictly on the application of this administration note. And we make it applicable to all new missions. So all ESA missions that have, where the development started after 2014, they do have all space debris mitigation requirements as stipulated by the IDC and ISO standards in there. So, and yes, Pascal said something very important. Europe is actually not a big contributor to the debris problem. So we are here at the European Space Week. So what should be the role for Europe in this? And I think we should be a role model. We have always been traditionally very strong on sustainability issues in Europe. So let's be a role model, and you can do a lot of things without guidelines, I must say. So, for example, we need to share information, tools, data, as they are doing in the space surveillance, but there's also data on space objects that is not orbit related that we are sharing with the world. There's also software that you need to understand the risk for your spacecraft and understand how to implement the mitigation actions, which we are very happy to share with everybody in the world, because we believe spreading good practices is what we need to do. Then in Europe, there are many countries with a long history of having a space law, France, for example. And there are other countries in the world that are thrown into the space age because suddenly a startup company settles down in that country and they don't know what to do. So let's bring these together. Let's bring the experienced and the non-experienced together. We are running workshops that try exactly this. So the unexperienced can learn from the experience, and we establish a good quality of standards, harmonize as much as possible, because what we don't want to see is a Cayman Islands for space debris somewhere. Indeed, and then we are all operators that have already spacecraft in space today. They are pragmatic people normally, so they're sitting together and discuss what kind of data do we need to exchange. What are your maneuver plans in the future? How agile is your platform? Can we develop a protocol that automatically exchanges that information so that we can leave it up to the computers to decide what needs to be done rather than exchanging emails when we get the conjunction alert. So these are the things that go without guidelines already.
Thank you, and it's really good to also to highlight that the engineering standards, they are also a bit similar than legal requirements being either or shall not. And the combination of those two especially is something very powerful and something that we can do. However, there's also one very important other possible way, which could be financing. So Roope, as a startup, you are, I'm sure, very aware, and it's one of your everyday issues to think about how to finance the operation. So would you think that including sustainability requirements in either public or private financing could be one way forward together with the other ones?
That probably would have to go through regulation as well, because there's so many financiers around that my job, of course, for the startup is to get money from somewhere, period. And if somebody puts points on that funding that you have to do this, and this first, I go for the lowest bar. Typically, of course, there are issues that you need to follow, and if you get funding from certain places, you might cut off other markets. But probably it's going to be quite difficult unless we put some regulation on the financiers themselves that you have to put this into the whole package. If you have a big crowd of people offering a service, they will do shopping of the best terms. And it applies to the countries as well. We don't want a Cayman Islands, and financing, I think Cayman Islands fits that question quite well. so that game is actually very difficult to play. So it comes back to your domain, legal part.
I'm glad to hear that regulation is even sometimes needed and necessary and welcome. But Ian, working with the companies in the US, is that something that you've seen to be one of the options, or what do you think about that?
The role of investors as a vector for responsible activity. So we've been having a series of conversations and hoping to build on that in the coming year around just that question. What role does the finance and investment segment of the space community have to play in encouraging, developing, and implementing responsible behavior? I think we heard yesterday in one of the panels that a lot of the investors aren't even necessarily aware of some of the challenges that we're talking about, right? They come in from the IT domain, they come in from the health domain, they come in from something else, and, oh, space is interesting and space is fun, I'm going to invest in a space company. Space debris is not something they're thinking about. The challenges of launch is not something, frequency coordination is not something that they're thinking about. So one of the things that we've uncovered in our discussions is that there's a need to actually build awareness within the space interest investor community, and I'm primarily talking about the venture community here rather than the institutional community, about some of the challenges and some of the risks to the space environment, which then in turn become risks to the sustainability of the investment environment in the space sector. The flip side of that is investors then often act as a conduit to the new actors coming into the space sector. So you may see the venture capital firms that are active in the space sector, as they interact with their portfolio companies and those portfolio companies come into the space sector from outside of it, the investors themselves can be a channel for distributing best practice, distributing common understanding. And so we think there is a role for both sides of that, but it's a conversation that needs to be brought up further. The other remark I wanted to act on the regulatory side of it. So if we look at investment practice in other non-space industries, there are principles that have been developed at the international level, principles for responsible investing, environmental and social governance principles that the investing community and outside of space does use to guide which companies they might invest in and maybe more likely to invest in that follow these principles. And I think we can look at whether some of those principles or those that can be adapted to our community.
So yes, if sustainability is seen by the investors that it gives you a better return, of course that will drive the market very quickly. And there are some studies that this is the case. But it's not going to be the only it's not going to be a one-stop shop anyway. So it's going to be a difficult game. And maybe more of a PR game than to get the investors on board. When 90% of the investors require it, then it's becoming a standard already. But we are not even close there yet.
Sure, and I think this discussion very much shows that how much there are so many different actors here relating to space, not only the actors who are actually carrying out space activities, but there are so many other stakeholders who can both influence but who are also affected by the space activities and the sustainability considerations, and that not only being the people here on the surface of the Earth possibly experiencing grave societal or economic consequences if the space services are not available. So I think we have to use all these ways to drive towards that direction. Just that also, because I think exactly because of the reason that there are so many actors and so many activities, we've covered a variety of different topics relating to sustainability. So being here in Finland, I think it could be the time to make a Christmas wish list about those topics that you could see as the first and foremost topics to be addressed now, to answer to the question that how we can make space usable now for us to provide the services that we need, but also to think about the future generations in the long-term sustainability world. And Natalia, if you could start from the UN level, maybe to wrap up the Christmas wish list.
Thank you very much. I'm sorry, since I'm the first, I just use a few seconds to think more. My first reaction was to your first question, how could we better use space now? I think here, I think in one word, cooperation. I think cooperation is key. It's key for helping emerging actors to use space now, to helping them to use space in a safer and more sustainable way, as Holger was highlighting, the question of having the technological capacities. And as for the future, I think it is really up to all of us to make huge efforts to preserve this wonderful resource that we have around Earth.
So there's a good thing that Christmas is every year. So my wish for Christmas 2019 is that we, as Europeans, go ahead, help industry getting the capability to remove an object from space, demonstrate that it works. Hopefully, by Christmas 2025, regulators will see that this can be done at a cheap price with a single-digit million or even less per piece. That's a job of a space agency to help making reduce that price to that level. When we achieve that regulators start writing into their regulation that if somebody fails to dispose this object with his own means, he would use a removal service, which would have two nice effects. Spacecraft operators will make sure that their spacecraft is able to dispose itself to a large degree, and for the remaining ones, there would also then be a solution. I think that's a step we have to take, and for Christmas 2020, I hope that we start understanding space as an element with a limited capacity, and think about in the more remote terms on future guidelines that take it from that end.
Thank you.
So this may be one that I need to ask for in several Christmases to build up the awareness of it, but it's just that, it's awareness. It's awareness of space sustainability challenges, risks, and efforts to mitigate those challenges and risks. So awareness within the customer and user community. So we talk about space sustainability within the operator and regulator world. Do those who are benefiting from the space systems and space applications, are they aware of the risks to those systems, and they are encouraging us to promote and protect the environment in which we operate in? So if the end user community becomes aware, that produces a more of a bottom-up emphasis on these issues and helps us solve it from a market standpoint.
Well, my wish, of course, is that the investor would ask that question about sustainability, because that would give me an advantage. They haven't asked that yet, and I talked to over 200 of them already. Of course, the other question is more concrete in a small company with these missions that actually work towards these sustainability issues, like the one that Holger was mentioning. We are participating in that, by the way. I hope that goes well, and more of those to come. Because that is the way forward. You know, you showcase, and then people learn from that and get inspired.
Yes, I think the situation is pretty good today in Europe. We had this ESA ministerial conference, and I'm very happy for Holger. The space safety program is in very good shape today, so with a lot of subscriptions. So this is very positive. I think it's Christmas before Christmas. And then at the European Union level, of course, 2020 will be a key year for all of us, and space surveillance and tracking, and SSA is today a component of the future space programs at EU level. And of course, we expect a lot. This European consortium of member states in space surveillance and tracking is moving into the right direction. We are progressing a lot. We are building this European database, sharing thousands of measurements every day, and this is unique in the world. We are improving the performance of our sensors. We are delivering top-class collision avoidance services. In French, again, I used to say this is haute couture services. And we expect, of course, to improve the autonomy at European level in these domains. So, of course, 2020 will be a key year for all of us, and in particular for these domains, space surveillance and tracking and SSA, in the next multi-financial framework. We expect a lot from that. Thank you.
Yeah, thank you. And Christmas before Christmas always sounds good. If you could choose, always take it twice. But I think it's really all the topics that we just reflected here about the risks and benefits, and how do we have to actually think about them, and to make people, the users and the operators aware, and to think about those, to stress cooperation amongst all these actors, and also the stakeholders who are not necessarily even sometimes considering to be space actors, be that the investors who I hope will come to speak to you, because you seem to be a forerunner with the sustainability topics as well, but to also to consider the regional roles in the global activities. So how we can bring the European leadership, or in a way to leadership, to say to lead by example, to show how these issues can be taken seriously, how can those be reflected in regulation, the guidelines, the standards, and possibly also either customer requirements or financing conditions, to really make a good blanket to deal with all the aspects. But it's really to incentivize all the actors, and to somehow not only ask to do what and by whom, but also everyone, bottom up or top down, to take responsibility to make space more sustainable. And I think this in a way concludes the discussion here, but since I think we have a break coming up, we will be able to continue the discussion over there as well. Thank you.
Let's give them a very big Thank you so much for a fantastic discussion. You know, it was great to get this insight, all these insights on how to keep our satellites healthy, but also how to give them a happy life and also a happy death. I think that's very, very critical. I enjoyed particularly what Holger said about the analogy with frequency bands and the power of regulation, and also what you said about speeding limits. You know, there are innovative regulations. Reminds me of my 2 Christmases ago. You know, Finland and Switzerland have a very interesting regulation on speeding limits. You know, you pay according to your salary, which is interesting because the richest people in these countries have broken a world record for how much money you can pay for a speeding ticket. In Switzerland, it's 800,000 euros for one speeding ticket, and Finland has the silver medal and the bronze medal, 200,000 and 100,000 for a speeding ticket. And curiously enough, the richest citizens have been very, very good citizens in terms of not breaking this rule. So maybe we need these kinds of regulations to keep our space healthier in the future. Let's continue the discussion over the coffee break, which will be a half an hour, and then we're back talking about space solutions for a sustainable Arctic region. Thank you very much. Thank you, panelists. Merci. Kiitoksia. Welcome back, ladies and gentlemen, for our final session in these plenary sessions of the European Space Week. How many of you have visited the Arctic region? How many of you? Okay, that's why you all came. Everybody's interested in the Arctic, of course. And it's perhaps one of the most fascinating places in this part of the world. Really recommend extending your stay next time to visit at least Finnish Lapland, an amazing place. And speaking of the Christmas list talked about in our last panel, well, you could always put in your Christmas list in Rovaniemi, Finland, of course, everybody knows is the home of Santa Claus. So there are many reasons to visit the Arctic, but many reasons to talk about the Arctic. The Arctic is facing tremendous impact from climate change, and we need to get more information, more data from space to make that area better. Already we've discussed the impact on the Arctic in various parts of our week, but now we're going to be discussing this specifically, space solutions for a sustainable Arctic. Our keynote speaker for this session, ladies and gentlemen, is also somebody working at the Finnish Meteorological Institute, they have been on the stage many times, and now for this one we are closing with one research professor from the Finnish Meteorological Institute. He's a director of space and Earth observation. He has a team of 100 researchers and technical staff working on this issue. So we're very much looking forward to his keynote speech this morning. Please welcome Jouni Pulliainen. Tervetuloa.
Kiitos, kiitos. Okay, so thank you and good morning to everyone, or good noon. So the session, topic of the session is space solutions for sustainable Arctic. And that means how can we use different space systems to support livelihoods and all the activities that are nowadays going on in the Arctic region and in the future as well. And as you all know, there are big changes and big opportunities in the Arctic coming from the decay of sea ice, also decay of global snow cover and the permafrost and such kind of issues. So there are all kind of changes happening. In some cases, they can produce into some new activities like shipping lines in the Arctic region, but in some cases, as you know, there can be drastic deterioration of different environmental ecological systems and that kind of things. And of course, the changes affect the global climate, which is also a topic where spaceborne observations can give a big help. So I will discuss a little bit about the current status and some words on the Finnish perspective on the issue as well. Overall, I think we can divide the main issues into 3 sections, and the first is, can be said, it is the gaps in observations. If you consider, for example, meteorological forecasting, meteorological forecasts, they are of course highly important for every activities on the planet, and the more sensitive the systems of humans, so regarding all logistics and economical issues, when they are becoming more sensitive and complicated, they are becoming more sensitive to weather. And so, in particular in Arctic areas, weather predictions and how you know the conditions beforehand, it's a highly important issue. But the handicap is that we do not have observational systems for the Arctic region. So current satellites are providing some information, but not as well as what we are getting for lower latitudes when we have all satellites in the geostationary orbits that are providing constant imaging. So regarding Arctic regions, we can only rely for spaceborne observations on the polar orbiting satellites, which are occasionally providing data. And that is a problem that has to be solved, and fortunately there is progress going on at the moment. And of course, European satellite systems like Copernicus family, Copernicus Sentinel satellite family is providing tools to improve that, and actually they have already done big improvements in that section. Weather prediction is also much connected to navigation, and satellite systems are also able to provide direct information usable for navigation in ice conditions, especially radar satellites, so synthetic aperture radar, SAR radar. And that is also a key technology to support all the activities in the Arctic. And that is also a safety issue. So all kind of accidents and what is causing accidents can be different ice conditions and different conditions. In general, we can also say that problems in the Arctic are rising due to such issues as the lack of sunlight. And because of that, also these, let's say, advanced technologies like using microwave radar, remote sensing are feasible tools. And then to add one thing, that in lower latitudes we can also have quite dense networks of in-situ observations, and that is not possible that much in the Arctic regions. And that is also a key topic that puts weight on the satellite observations and emphasizes the need of satellite observations. Well then, that was the first topic. Then if we consider the second topic, that is accurate navigation information, so positioning information. And there we also have problems, even though new systems are rising. And that is coming from the orbits of the satellites. So they do not go, if you consider GPS or Galileo system, they do not cover the highest latitudes as well as the lower latitudes. And then another issue is coming from the ionosphere. And so the electrons in the ionosphere, they are making more complicated the positioning and thereby the navigation. And these are also issues in which we need further activities, like information on the space weather and how that affects into the positioning accuracy. Well, then the third big issue is the connectivity. So if we consider that there is nowadays going on a big measurement campaign related to climate change, so Mosaic campaign, in which there are vessels going on in the Arctic region. But funny thing is that there is not much data connection into the vessels that are moving in the Arctic regions. And therefore, there is an evident need to have communication satellite systems that can support activities in the Arctic region. So that was the third issue. And as a consequence on all these three problems, we have effects to the safety, and also an important aspect is that the availability of observations for environment and climate monitoring and research is limited. So Arctic regions form an area for which we don't have enough information. And there is also a need for satellite systems for future and for the improved utilization of current systems. Fortunately, pretty much can be done with current systems, especially Sentinel satellites of the Copernicus program. And then there are other organizations like EUMETSAT, European Space Agency, which are active in putting new experimental and operational kind of systems to support all kind of activities related to Arctic areas. So that means operational things, and that means research things. And I guess in the panel discussion today, we will continue in these issues which are highly relevant for the Finland, because Finland is a north-located country, so we are pretty much sensitive to all these issues that I introduced here, and we are therefore also doing pretty much of research and development work related to these issues in order to improve the satellite systems and their utilization for the Arctic and northern regions. So thank you, and let's go to the panel next.
Thank you so much, Joni, for that great kickoff to our great panel discussions that is ahead. Ladies and gentlemen, there are a lot of issues, as Joni mentioned, that need to be addressed for a sustainable future in the Arctic, and how space can be a part of that. And who better to be the moderator of this session than the director of the multidisciplinary research platform of the digital economy at the University of Vasa. She's a professor of computer science, research professor in satellite navigation at the Finnish Geospatial Research Institute of the National Land Survey of Finland. Ladies and gentlemen, please give a warm welcome to our moderator and to all of the panelists coming on stage now. Professor Heidi Kuusniemi from Vasa University. Tervetuloa. Welcome.
please take a seat. Yeah. Hello, everyone. Thank you very much for that kind introduction, and thank you to Professor Jouni Pulliainen for the excellent keynote speech. It's my privilege and honor to be moderating this last panel of the plenary session of the EU Space Week 2019 here in Helsinki, Space Solutions for Sustainable Arctic. The event has been such a success, and I'm looking forward now to our discussions on Arctic topics. I myself, a navigator, have been my whole career specially focused and working with GNSS. And many of the research developments that I have been involved with have been towards robust and reliable navigation and situational awareness, also for Arctic waters and wintertime navigation. Importance of the Arctic is growing. The Arctic region is warming up more than twice as fast as the rest of the globe. The ice is melting and the permafrost thawing. The Arctic is increasingly a global issue. The greater economic activity foreseen in the Arctic will increase environmental impacts and risks there, leading to having to develop actively solutions for a sustainable Arctic. Thus, our panel today discusses space solutions in particular for a sustainable Arctic, satellite communication, navigation, and remote sensing and Earth observation. Let me now introduce to you our distinguished panelists. First, we have Mauro Facchini. He's the head of the Copernicus unit at the European Commission in DG GROW. Mauro has a background with a PhD in mechanical engineering. Before joining the European Commission, he has worked in Italy, UK, Switzerland, mostly in the academic and research environment. He joined the European Commission in 2002, where he initially involved in management of research projects funded by the EU. He's been involved in space aspects and participated to the definition of the European space policy from its early days. He has actively been involved in development of Earth observation capacities at the European Commission in the program initially known as the GMES. He was appointed head of Space Research Unit and led the preparation of the space-related part of Horizon 2020, and since 2014 he is the head of Copernicus, the Earth observation program for Europe. Welcome. Then our next panelist is Pierre Bahurel. He's the Director General of Mercator Ocean International, the operational center for global ocean monitoring and forecasting. He graduated from École Polytechnique in France, has worked with space altimetry modeling and data assimilation applied to operational oceanography, and was among the founders of Mercator Ocean in 1995, which he has been leading and developing since then. He holds an executive MBA as well from the HEC School of Management. Pierre manages today one of the world's leading centers that delivers operational ocean information worldwide. In his leadership, Mercator Ocean International was entrusted by the European Union in 2014 for implementing the marine component of the EU's Copernicus program, the Copernicus Marine Monitoring Service that we will most likely also be discussing in this panel. This European service is recognized today by thousands of users worldwide as a unique source of timely, reliable, and state-of-the-art information on the physical and biochemical state of the world ocean. Welcome. Then next, I would like to introduce you to our panelist, Tero Vauraste. He is the CEO of Nurminen Logistics PLC, a Finnish logistics service provider with operations in Finland, the Baltics, Russia, and China. During 2018 to 19, he has worked as an owner and managing director of Mariadi Limited, an Arctic maritime and business consultancy agency serving international clientele. From 2009 to 2018, he served as the president and the CEO of Arctia Limited, the Finnish polar maritime servicing company in icebreaking, research and oil spill response, operating 11 icebreakers in the Baltic Sea and the Arctic. Tero Vauraste has served the Arctic Economic Council since its initiation in 2014. He was the chairman during the Finnish Business Community's chairmanship 2017 to 19 and is currently the vice chairman of the Arctic Economic Council. He has a degree in risk, crisis and disaster management from Leicester University and a naval officer's degree from the Finnish Naval Academy, being a lieutenant commander. He has served as a vessel master, special unit commander, and a search and rescue instructor in the Finnish Coast Guard. Among his many positions of trust, he's also the chairman of Finnish Arctic Society and a member of the advisory board of the Finnish Lifeboat Institution. He has also provided many influential papers on Arctic economic development and is a well-known speaker in the International Arctic Fora. Welcome. Then next I would like to introduce you to Karno Tenovuo. He has been in the marine business since 2004, launched several groundbreaking solutions to the market. He's now the CEO of Awake.ai. He received his Master of Science in Technology from Helsinki University of Technology and Master of Science in Economics from Turku University. First 7 years he worked at the Finnish shipyards, leading R&D and business development, and then he started his own company, and Rolls-Royce became one of his customers and soon was offered a global role heading business development and strategy based in Norway. After that, Karno started the research on future ship operations and then grew that into ship intelligence business, and some highlights of those projects included Maersk and Switzer that demonstrated the world's first remotely controlled commercial vessel. So he has been working on the first autonomous commercial ship demonstration in the world. Then he realized that autonomous ships cannot interact with the rest of the logistics chain unless the needed digital handshakes and machine learning models are being developed and linked to an open platform, and therefore Awake.ai was born. So welcome, Karno. And then last but not least, our last panelist is Dan Kirondoyan. He's the Director for Space, Security and Migration since 2016 in the DG Joint Research Center, the European Commission, JRC, the Scientific and Knowledge Service of the European Commission. The mission of the Directorate is to focus on research and knowledge management regarding technology innovation in security, disaster risk, emergency management, cybersecurity, hybrid threats, transport and border security, safety and security of buildings and public spaces, critical infrastructure protection, space-based services and applications, as well as migration and demography. Prior to that, for 5 years, he was Director for the Management of Infrastructure and Services for the JRC site in Ispra. And before joining the European Commission, he spent 17 years in the private sector of electronic communications in Romania, being in charge with operations of the infrastructure associated with radio and fixed networks, business continuity planning, security risk assessment, and crisis management. Welcome. Okay, I'll also take a seat and then we can start our discussion. Okay, I would like to start with a question to Mauro. As the head of the Copernicus unit, in your opinion, what is the relation and importance that you see for the Arctic to the EU as a whole, or to the Central and Southern European countries, considering, for example, transport, economy, and the environment?
Yes, thank you very much. And first of all, let me say that I'm very happy to be here I think it's very refreshing, not in the sense that it's cold outside and it's not so cold, but because it's very nice to see people that are really involved in these space activities. Sometimes when we develop that one from our side, we are closing our offices, we run all the time doing that, but seeing people that use what we do is really the best reward and the main justification to continue in that direction. So, coming to your question, Arctic and why it matters to the EU and to the southern countries and so on. I imagine you're asking me that because I'm Italian and so I'm not very linked to Arctic. But I think that Arctic matters to everyone in some way. I was just reading out of curiosity some chaos theory that says that the butterfly that is flapping wings in Mexico can produce earthquakes or typhoons in China. We don't need to go so deep into chaos theory to understand that what's happening in the Arctic can bring really impacts everywhere in the world, and in particular in Europe from our perspectives. There are actually several aspects that are very close to our heart, and the first impact is for sure the climate. Because when we look at changes in the Arctic, it's dramatic what it can bring in changes in the environmental aspects and challenges of the whole world. Reflection from ice sheets or circulation of the oceans, and so everything can also start from the Arctic, and the impacts are everywhere. So climate change in that respect is very important. I was myself, I think, 3 months ago in Alaska, and it was dramatic to see the roads. Sometimes people just think about ice sheets, but the roads were like roller coasters due to the fact that the permafrost is changing, and actually you see these roads that are getting crazy from one year to the other. So we have to act, we have to do things in order to see and to preserve what's happening in the Arctic. So Arctic, as said, is for climate, but at the same time it can be an opportunity. As you said, it can be for transport, other activities, but this has to be done in a sustainable way. It has to be done as sustainable development. And this is very important because it's true that Arctic is providing also opportunities, for example, for gas and other resources, but we have to treat that in a very wise way, I have to say, because we risk really to damage even more that area. And finally, it's an area that is not just close to Finland, to Norway, and so to the European side, and I include in Norway and as well in Iceland, because it might seem quite strange, but Norway and Iceland are the only non-EU member states that are part of Copernicus. And so this point of bringing Arctic as an important thing for what we do is also linked to that. So, yeah, as I said, there is also Russia, United States, Canada. So it's really an opportunity for international cooperation. It's an area where we have to cooperate together to defend it. It's true that I'm coming from Earth observation, but it's not just that. It's about navigation, it's about telecommunication, it's about weather predictions, but I will not get too much into that, maybe later during the discussion. Thank you.
Thank you. And please feel free to pick up anything if there's something that you would like to comment on when we proceed with the discussion. But if we move forward from this question, I would like to ask from Dan, related to the activities in the Arctic. I am aware of that the Joint Research Center, JRC, is just finalizing a study on space solutions and the Arctic. What are the key findings of this study, and is there something that you could highlight from this study in particular about how we can capitalize even more on the European space programs for the sustainable development in the Arctic?
Thank you, Heidi. In fact, yes, GRC has performed this study at the request of our colleagues. Mauro is very much aware of this. So we were looking to, the study has two scopes. One is to look to the user needs, and we know that there are 4 million people in Arctic. And if we speak about user needs, we speak about three main areas. It's about safe transport, and we speak here about maritime and aviation. It's about protection of environment, and sustainability is something that is very important. And it's about the connectivity between people, telecommunication. So we look to these user needs and versus the 4 domains of the EU space program. And you know very well, observation, navigation, telecommunication, and space situational awareness. If for observation and navigation, the results are quite remarkable, although there are some room for improvement, and we will discuss further. The situation for telecommunication is quite, let's say so, demanding. And here we see a lot of opportunities for improvement. And I will mention later some of these solutions. On top of that, we look to some concrete measures how to improve this situation. And in fact, we found that we should look for further synergies between these areas, and I'm speaking mainly because the panel previous touched the space situational awareness. I will not touch this. I will speak only about the 3. So observation, navigation, and telecommunication. So better synergies between these 3 can improve on all of this, but with focus on telecommunication. So later I will explain more what these synergies can be and how, what solution can be found for this.
Okay, thank you. Then next, I would like to ask Pierre, what are the links between all the Copernicus services and the Arctic policy, and also the future evolution of Copernicus? What are the future missions that can benefit to the Arctic in particular?
Good morning. So 2 questions. The first is about the connection between the Copernicus and the Arctic policy. So maybe it's useful to remind you that Copernicus is about satellites and services. Services are bringing transforming data into information to bring into the market. And we have 6 core services. The 2 are the emergency and security, and 4 about environment, from climate to atmosphere, land and ocean. And we are all connected to the Arctic. I mean, think about the maritime surveillance and fight against pollution, for instance, or the fact that we want to monitor the changes in the Arctic environment, which is necessary and which is done by for the atmosphere, for the land and for marine, and of course with assessment on the climate trends. The Arctic policy, there are three pillars in the Arctic policy. There is the monitoring of the changes of the environment. This is about sustainable development, so activity, and this is about international cooperations. So if I take the example of the Marine Service, remind me that the Arctic is an ocean. If we look at the environmental aspect, we are monitoring the Arctic environment in real time. So we are providing information about the ice coverage, the ice drift, the ice concentration, but also the temperature, the salinity, the currents, etc. And also all the information we could have on the biogeochemistry component. And typically we have for the moment the polar stern, which is somewhere in the Arctic, and we are able to provide them with information about the ice drift, which was not possible, say, 20 years ago. We are also assessing the trends of the Arctic and the melting of the ice, so the loss of 15% of the ice volume is observed and simulated by Copernicus, not only by the satellites, but also by the 3-dimensional models that we are developing and running for Copernicus. And this is something which is assessed every year, is something we call the Ocean State Report, where we can explicitly and clearly explain what we know today, what our experts in Europe know today about the Arctic environment. So this is for the first component. Talking about the sustainable development, which is supporting the development of activity through a sustained way. Some examples. We were 2 weeks ago here in Helsinki with the Copernicus Marine Service to organize a workshop with the users, and I just want to explain, to give you a few examples. We are working with startups in the maritime sectors. For instance, Nautic AI or Fleet Range, they are providing information for situational awareness, operational information you need when you're at sea, and they are using the open and free data coming from the Copernicus marine environment. This is one set of information added to other that are about the operational situations. Second example, we are in contact with the Natural Environment Institute, LUK, from Finland. I'm only talking about examples for Finland. And they are assessing the environment against their objective to install installations for the rainbow trout, growing rainbow trout. And they decide with what we have from information if this is a good place or not, a good location, and then to manage this activity. And the third example about this Finnish Meteorological Institute, two things they can do with what we have today. They are starting a service which is about the fast ice extent, just for the people to know the situation of the ice along the coast, the ice roads, etc., and something which is more operational, which is the connection with the ice services, which is a strong cooperation we have in Europe with the European ice services, Finland, but also Norway, Sweden, Denmark, Germany, etc. So this is about international cooperation. We have also, we are thinking about having a high-level agreement with the International Ice Chart Working Group. So we had a workshop with them. And last but not least, the unit of Mauro, who is monitoring what we do, has signed an agreement with Canada to develop together activity on the Arctic. So environment, sustainable development, and international cooperation is really something which is in common between Copernicus and the Arctic policy. You have a second question?
Yeah, the other question was about the 3 candidate missions for polar observations. Can you explain a little bit more about those?
Okay, so there are 6 satellite missions that are foreseen, and 3 out of 6 are about the Arctic. There is one with imaging radiometer, which is good for monitoring the environment of the Arctic. The second one is Crystal, which is good for the high latitude and also for the ice thickness. And the third one is Rose, which is interesting for human activities at sea, for assess or observing floating objects, ships or pollution, etc. So the good news is that it seems that the Arctic is really a priority, which is excellent, and you can be sure that all the Copernicus framework is really committed to really support from the observations to the services, and also that we are covering these two components, that is the environment monitoring with the 2 first missions, and also the climate trends, which is very, very important for this, but also the support of human activities. So what is going on now is that there are these studies that are going on with the European Space Agency, and we, at the services level, we are learning how to assimilate very quickly all this kind of information. And we are already clear about the impact that this kind of missions, the observations, will have on the quality of our services, on our information for the end users. And we will be ready when these data are there to really improve the services into this direction.
Okay, thank you. Then, yes, sure.
Yes, maybe to complement on the last part, on the missions. Actually, the selection of the 6 missions has not been a top-down decision. It has been the result of more than 2 years interaction with users. So we had workshops, we had meetings, we had surveys, and so on. At the end of the day, we decided and we proposed that 4 areas were of interest, and among the 4 areas, the Arctic was one of those. Then the fact is that this 4 area materialized in 3 different missions, and so this is the reason why we ended up with 6 possible missions. As was said by Pierre, the studies are ongoing. You asked about the timeline. This will take some time, but in our plans, I would say 2026, 2027 could be a potential date where we could foresee to launch these satellites. Then, I mean, nothing is cast in stone. There are many variables. It's technical issues. It's also financing, because we also to see how much financing will be available for that. So ESA, as was mentioned yesterday, has been very successful during their ministerial. We have still to stabilize our budget on the MFF for the next 7 years. So based on that, I think we'll be more clear, I would say probably next year, on what will be the deadlines for and the timeline for the launch of these missions.
Thank you. Sounds excellent with the Copernicus evolution, also for the Arctic. Then if we move a little bit towards satellite navigation, a question to Tero. How do you see that satellite navigation services and applications can support the economic development and all the communities in the Arctic?
Well, let me start with a practical example from a couple of years back when the Finnish icebreaker Fennica was about to leave Dutch Harbor in Alaska in the Arctic waters. The conditions were not poor, but not very good either. The pilot was on board, and there were 2 possible fairways to get out from the harbor, the western fairway and the eastern fairway. The master had decided to take the eastern fairway, but the pilot recommended on taking the western fairway out of the harbor because there would be less swell, so it would be easier for him to get out from the vessel. So the pilot and the master made this decision, and they started going out from the harbor. And after navigating for several minutes, some of the people on board, not everybody, but some of the people on board just felt a small, like a move. And some people on board heard something. The master didn't notice anything, but some of the deckhands noticed something, and some people heard sort of a clang. Well, they continued navigation, and the pilot went out of the vessel, and the duty officer noted that something might be wrong. So he started looking into the ballast water tanks, whether there will be leakages or if there is something wrong with the movements of the vessel. And after navigating for 4 hours, he was sure that one of the ballast water tanks is getting water in, so there must be a leak. So once they had noticed this, of course, the decision was very rapidly made that they will return to the harbor. And that's what they did. So what was found on the vessel was that there was a gasp in the hull, a hole, and the vessel took in water. And this is an example of the dangers in the Arctic waters, because there was 3 or 4 meters less water in the area where they were navigating compared to what the sea chart indicated. These types of situations may occur in the Arctic area, so what would be the opportunities for satellite information to provide safety for this? It's ensuring the bathymetric information, because only 3 or 4 or 5% of the Arctic waters has been sort of charted in a reliable manner, and if we would find a way to use the satellite pictures with the help of specters and other technical measures to secure the bathymetric data, that would be a great step ahead. That's not possible for the moment, but I hope that that will be an opportunity in the future. We would have avoided this accident with this type of information. Secondly, considering sustainable development, that would be providing optimization of the navigational routes based on ice data, based on expectations of the ice developments, and of course on the weather developments, because that gives you an opportunity of finding reduced need for using the energy in the vessel, which is of course then good for the environment because you will have less emissions from the vessel. So using the data which we can gain from the satellites for route optimization would be my second suggestion.
Thank you. Then a question to Karno, also focusing on the maritime sector. From your experience, how does the maritime sector generally in the Arctic benefit from the various space assets now related to Earth observation, navigation, and satellite communications from your perspectives and experiences?
Okay, thanks. There are multiple aspects we need to consider here. First, regarding Earth observation. Of course, the sensor fusion of that data, whether it's rain or wind or ice, it's really important. That needs to be used for the navigational purposes that I was just highlighting. And of course, yes, I also like to point out the use of AIS data for navigation decisions and for routing information, and that's very crucial. I see also in the future maybe this could be more used for emission and pollution regulations, kind of ensuring that those are followed. But then the big thing, what we are working on is, of course, related to this future remote control and autonomous vessels. They will operate in the Arctic as well as they will operate in many other areas as well. And what you need to do there is basically we need a new type of connectivity. Exactly 1 year ago we did a demonstration here in the Finnish archipelago, and of course considering that you need basically if you want the operator to have a full feeling of control, you need at least 100 millisecond delay in the controls, and you need about 5 megabyte bandwidth two-way. So how do you actually ensure that? If you only use it for kind of navigational decisions and routing information, maybe the frequency of the information can be every 15 minutes or 30 minutes, but if you need it for controls, then you need something totally different. And the other thing to consider here is how do you ensure the resilience of the positioning information? So how do you ensure the integrity? There comes basically it all comes down to sensor trustworthiness. Do you actually trust that the data you are receiving is the one that is real, and has it been altered along the way? How do you ensure that? And here is where space technology and solutions can really help.
Can you elaborate a little bit more the data fusion and the AI related to using all the data, so the opportunities and also risks, a little bit in more detail? What do you see as what are the possibilities, but also risks?
Yeah, of course, now we're considering for example, what we're doing, we're developing the AI models for the operations optimization and these kind of things. There comes basically the operational timestamps that comes from operational systems, but then that needs to be fused with, for example, the weather data. How do if you consider, for example, the turnaround times in ports, the key aspects is really that where does the rain actually hit and when? What is the wind direction and speed that can we actually safely do the operations? And if there's ice that needs to be cleared along the way, can you create those predictions? Is the data there that you can fuse that with the other operational data so that the models can predict when certain services are really happening? And that's the kind of data fusion that we're talking about.
Yeah, thank you. We talked a little bit about Copernicus evolution for the Arctic, but what about then the Galileo and EGNOS evolution for the Arctic? What are the possibilities, and what do you see as are the largest benefits in the future lying there? Dan?
Okay, thank you for the question. In fact, I will try to explain better some of the measures that we think that can be applied to find some synergies between Galileo and Copernicus, but also satellite communication for Arctic, and I will give 5 examples. So, as I mentioned, first one, it's about telecommunications. So in Arctic, there is a clear need of better telecommunication, and I'm speaking about 2-dimension coverage is extremely important, but also capacity. We speak about real-time control. It's very important to be able to send the right information at the right moment and to be accurate. How this can be done? Obviously, that we can use payloads that are put on current satellites or on commercial satellites. It will be a lot. We heard here a lot of new companies launching satellites. We know about Iridium that already is there, Argos. We heard about OneWeb. So there is a lot of opportunity to use these satellites to improve telecommunication in Arctic zone. The second example is about ice mapping. This is very important in Arctic, and we speak about dimension, shape, depth, about the shift of ice is extremely important, and here we can have this approach of combining some of the Copernicus services, information with communication and with increased automatic processing and machine learning. This is something, and it's very linked with artificial intelligence, that you said we can use this information in a better way. The third example is about, very linked with what Tero was saying, about underwater depth, the so-called bathymetry. So we are researching now the possibilities to use the satellite data and information signals to measure the depth under the ice, which is extremely important, and with the melting of the ice, this will be even more and more important. And obviously, this is linked with the possibility to communicate this. It's okay, yeah? To transmit this in real time. The fourth example is related to the, and this is very much linked with Galileo, it's about search and rescue operations, which are extremely important for the Arctic, which generally are isolated areas, and it's not so easy, for example, for medical services to arrive to the people in need. And an important feature of Galileo will be this return link. This will be, that will be in operation from the beginning of next year. And in fact, it's a confirmation that the message sent by the person in need was recepted. This is extremely important because it will give a kind of psychological comfort to the person in need, knowing that the signal that he or she sent was received and somebody will come. And the fifth example is a kind of combination of this. It's about emergency warning service and situational awareness in the combination of some of these in such a way that can make sense for the users and can be transmitted to the users in real time in such a way that they can be aware of any possible risk for them that can appear in the future. Thank you.
Maybe just to complement, because actually your question was mostly, I would say, on the navigation side. So I'm not the navigation expert, but I think that discussing also with colleagues and having briefings about that, I think is always very useful. And we have already recognized today that EGNOS is available, and EGNOS can already provide support up to 72 degrees, and soon this can be even improved up to 75 degrees. I think this is planned for 2024 for what they call the safety of life services. And I understand that also with cooperation with other countries, in particular with the Americans and with GPS, so Galileo and GPS could provide by 2030 safety of life all over the Arctic region. This is for safety of life. Another aspect is the search and rescue service of Galileo. That would be very important in order to support some rescue activities, some problems. This will also bring additional help And just to give a figure that I got from my colleagues, they say that without Galileo it would take up to 4 hours for the distress signal to be detected, and the search area would be up to 10 kilometers. With Galileo at work, the time it takes to detect the signal is just under 10 minutes, and the localization area will be down to 2 kilometers. So I think faster and more precise.
Yes, excellent, thank you. Now, staying a little bit on the topic of precision and accuracy and navigation accuracy, and the evolution of Galileo and these future upcoming services also in the near future, and then the evolution of also EGNOS. Karn also mentioned integrity. In your opinion, what is the necessary accuracy, integrity, reliability needed for various Arctic operations and activities? How accurate do we need for different applications of the Arctic?
Well, if I just say some words here, so as I mentioned, accuracy is extremely important, because we saw that these synergies need to be better analyzed, and to see on a case-by-case for each of these services what is the best way to go forward. I think that I want to mention here the important program for research and innovation, Horizon Europe, that will foresee a lot of research in these areas, and definitely also in addition to the missions that were mentioned by Mauro and Pierre, this research on specific topics will make these kind of things and to see what is the exactly accuracy for example, for ice mapping, which should be maybe different than for, I don't know, localization of search and rescue. I think that is important to understand and to have a scientific approach, not just because we heard to the previous panel about this 90% probability of having the satellite up and running for 25 years, which is not so much, because 10% this means that will become debris. Yeah? So I think that it's important to have scientific and technical analysis that can support this, so bottom up, and then a top down to have a clear governance and a clear standardization process that can impose these technical limits at the level of the global level, I can say.
Yeah, I can add something to say that who's asking the question? I mean, the accuracy. I mean, if you want to understand what is going on with the climate in the Arctic, this is different from a question asked by the ship captain asking for the situation for today or for the coming days. So we must be driven by this, by the who's asking the question. And also the fact that there is something which we can see here is that we are moving towards this a systemic approach where we can combine Galileo with Copernicus for the communication and the environment, the global view and the local view by the expert service providers that they have their own activity and their own expertise, and so the accuracy and the level of service will be dependent upon where you are in this system. But there is one component which is missing, which is the need of observations locally, the local observations, the in-situ observations. We cannot do what we pretend to, what we promise, if we don't combine this satellite observations or satellite communication with something which is on site, on the boat or on land or at sea, etc. And when you're asking about the accuracy, this is clear to me that we will provide something which is good as a core information provided as the EU information, and then we will combine with what we have as in-situ observations and satellite observations and expert and modeling, etc. But then when you want to decide and act, you must have with you a dashboard where you could add more information, more professional or more local information, and this is what the new technology is about today, to combine everything. So we cannot answer to these questions, but be sure that we are completely driven by this. I mean, we know what we want for assessing the climate trends. We know what we want to assess the evolution of the heat content, of the ice concentration, etc. And we know what we need to provide to the operational ice services so that they can themselves activate their own expert system to decide what they need to do.
Carlo.
No, I'm sure plenty of people have many comments here about what's the accuracy need. Of course, if you talk about docking or these kind of things, you want centimeter accuracy. But one concept that isn't really covered here is the connectivity degradation that happens when you move from area to area. When the accuracy then decreases suddenly, how do you manage that risk? So it's not about, what is the accuracy at a certain stage, is how do you actually manage the degradation? And that's something that there needs to be systems developed for that as well. So how do you maintain a constant accuracy that you can trust when you move from area to area? That's something that should be also focused.
Yes.
Maybe Tero was trying to say something.
Of course, it depends on the area of navigation and the topic of the operation. If you're doing dynamic position operations with a technical installment, the accuracy requirement is maybe centimeters or tens of centimeters. On open water navigation, maybe meters. On narrow straits, maybe 50 centimeters or 1 meter. But I would also like to highlight the human technology interface factor, because the more accurate information we receive, the less vigilant we become. We have noticed and witnessed this in many maritime accidents. One example is the Sally Albatross accident in the 1990s here on Gulf of Finland, not on the Arctic waters, but in icy conditions, where the root cause was the fact that the human technology interface didn't work, and the master of the vessel and the deck officers of the vessel were not up to their tasks in terms of the technological use of their operations. So whatever we use, however we use, we should also bear in mind the fact that this risk-aversive behavior is a part of the human nature, and we need to take that into account.
Yeah, I'd just like to add something, that if you compare what the kind of sensors that are used on either on the ship side or the land side, what's the accuracy of that? Today you can have a LiDAR system that gives you 1 centimeter level of accuracy up to 1 kilometer. If you use a camera-based system with HD quality, you can go up to several kilometers, but then the accuracy is some meters at max. So, comparing that to what we used for satellites, then, it should be somewhere along that range, I would say.
Did you, Mauro, have some?
Yes, I have to say it's also a matter of technology and evolution, because let's not think about Arctic. Let's speak about our countries, and let's go back to 10 or 20 years ago. So with the technology that we had for Earth observation, we were quite happy of having resolution 2, 3, 5, 10 meters, and even the concept of high resolution, very high resolution changed over the years. Same thing for navigation. I think some years ago we might have been happy to have navigation systems with a resolution of 2, 3, 4 meters, and now we're speaking of Galileo possibly reaching 20 centimeters. So it's an evolution. For sure, we are not at that level yet in the Arctic region. Maybe the requirements are lower, but I think that the requests will increase more and more, and the technology will have to fulfill that for several reasons. Because the more you give, the more it's asked. Then it's a balance between what is really needed and what is asked, and there maybe there can be a discussion. It's true that we will move more and more into the Arctic. Imagine you are in Helsinki today. Imagine that you switch off all the satellite systems. So actually, this is the situation more or less that you have in the Arctic. So you have no navigation, you have almost no navigation, you have also almost no Earth observation, limited telecommunications, and so on. We might say, okay, we don't care. In the end, Arctic is up there, so no one cares. But this is not the truth. More and more, we want to know about that area, and more people are going there. So we need to provide to that area the same capacities that we have here. And if you look, for example, at the coverage of most Earth observation satellites, you see really a black hole on that part. And this is not acceptable in the sense that people there feel lost. So there are some more traditional technologies, but we think that space capacities can bring something in this respect. So new orbits, new observation mechanisms, new solutions, and so on. And this, first of all, bring the signal there, and maybe also look later into possibility increasing the resolutions, respecting the needs of those being there.
Okay, thank you. Earlier in the discussion, what was mentioned quite often is collaboration, international collaboration. So I would like to discuss about that now in a little bit more detail, and focus first on the EU. How is the EU cooperating with other Arctic stakeholders on space matters in science, Earth observation, navigation, telecommunication?
So I might start by saying that when we adopted the space strategy in 2016, we had several priorities, several new priorities. We mentioned yesterday observation of CO2 or anthropogenic emissions was probably the first one, but Arctic observation were also very important. I have also to say that also at the level of the Council now we are discussing aspects that are really called like the title of this session, that is Space Solution for a Sustainable Arctic. And it's something that is done by our services, but for example, our External Action Service, because really the international dimension in this respect is very important. So, as I said in the beginning, the Arctic is not Norway only, it's not Finland only, it's not Denmark, Greenland, and so on, but there are other countries that are involved into that, Russia, Canada, United States. So it's a common endeavor, it's something that has to be done together. Maybe the interests are different. I'm not saying that every country around the Arctic has the same interest, but for sure we have to try to cooperate in a way that we can improve observations in that respect. As we are trying to do, for example, for the CO2 monitoring, to bring around international partners in order to have a global view of that, I think that also for the Arctic part, it's important to establish bilateral or multilateral cooperations in order to cover that aspect. And there are already several fora, Circular Arctic and so on, that are running these aspects, where space probably has to increase its voice as a potential, not policy, as a potential tool in support to the Arctic policy. And this has to be done in an international way.
If I can add something to what Mauro said, yes, international cooperation is extremely important, and in fact, the think tank of the Commission, EPAC, did a study related to Arctic, and it emerged that there are two, let's say so, group of countries, yeah? So the European one mainly are looking for protection of the environment and this sustainability in the future. There is another group which are looking more to security, geopolitical interest, and speak about Russia, China, even the United States. So what this means that by sure the interests are different, are not the same. So we should not be naive, yeah? And here I'm also, I want to highlight the dual use of the satellite. Yeah, I think that the satellite is a very good example of dual use. What means dual use? It means for civil, let's say so, protection of environment, sustainability, communication, navigation, but also for, I don't say military, but for geopolitical interest, security, yeah? And it's clear that here strategic autonomy is very important. Mauro said, what about if a satellite will be shut off, yeah? So what about if GPS, yeah? But now we have Galileo, fortunately. So we did some steps forward, but we should keep always in mind that this kind of technology has more and more this dual-use dimension that was not before. So now is happening that technology is evolving so fast, then even the security community and defense community are taking products off the shelf and using for their services, for their interest. So it's not anymore a separate area, portfolio of products for security and defense. So this means that this dual use and this dimension should be taken into account always when we design new services, new applications, and we should be very honest and not naive to say that there are people that are thinking when a new product appears, they are thinking only to the other use of the product, yeah, for the bad guys, yeah? There are people who are like this. So I think that this is something important, and we should have this in mind always when we speak about sustainability. Thank you.
Yes, thank you. Then about other organizations such as the Arctic Council, the Arctic Economic Council, and how are space matters discussed and planned? What are the objectives of space matters in those forums?
Well, let's first remember that the European Union is expected to renew the Arctic strategy, and that I think is of high importance. And I'm also looking forward to Finnish input from our presidency of the EU to that. Considering the Arctic Council and the Arctic Economic Council, there are no specific working groups for space issues as we speak, but I would wish that within the next year or two there would be also space-related and satellite services related working groups in both organizations. The organization signed a memorandum of understanding for the workgroup collaboration in the sidelines of the ministerial meeting last May in Rovaniemi, and that has already materialized. So last October we had a big meeting between the working groups in Reykjavik, where we had for the first time the working group chairs and more than 100 experts in the room in Reykjavik. So that has been put into practice. So I think there is a good and common ground to work in terms of these areas. Of course, areas like connectivity, areas like maritime activity are on the agenda of both of the organizations, but there is definitely room for increased collaboration and increased work for satellite and space issues in both organizations.
Okay, before we go to our audience questions, one last thing that I would like us to discuss is the policy matters. What kind, in your opinion, what kind of policy actions are needed to enable the key scientific and commercial opportunities in the Arctic?
There is two things which are of high importance. First one is that we are facing an era of increased protectionism, which is endangering sustainable development, especially in the Arctic areas. So the message to the decision makers is that lower down the barriers of trade and get out of the trade war and get back to the era of free trade. Of course, we understand that for the moment this is a high wish, but that's item number one. Second item is the expectations on regulation. So we should have as unified regulations of high standards in the Arctic area, so no big differences in different types of areas in the Arctic in terms of regulation, because that endangers the return on your investments. We understand that this is a high challenge as well, but those would be the two wishes from the business community.
Yeah, just to continue, you mentioned standards. So there are many areas where there are no standards today, and there are many areas where there are competing groups developing standards, and I think both are wrong. So we should work together to building a common set of standards for the Arctic operations and using I think space industry as a reference industry for the marine sector, for example, which every industry, when it goes through a transition, it needs the reference industry where to base their transition on. And for the marine, I think space industry would be the best option to choose from. You can go for cars or trains or mining or these kind of things, but still, I think space is the most relevant one. And when building, new set of standards for a market, everybody's today. They're trying to develop their own. And I'm just saying to everybody, please don't, and join a group and let's do it together. So create common standards. Everybody wins.
Great, thank you. And now we will be moving to audience questions, and I know that Tero has a time restriction in a couple of minutes, so if you have something for Tero, please hurry. But otherwise, the floor is open now for audience questions.
Hi, Martin from Austria. I work for Courier, which is a daily newspaper. So when we talk about climate change and the Arctic, much you have been discussing today is what will happen in 5 years with new satellites and new data. But as we know, it's like time is running out. So what will happen like in between? I mean, will there be progress before these new satellites and programs are in place?
So I think that our activities for, I'm speaking on the Earth observation satellite, and maybe then I come back a little bit on the SatNav satellite navigation part. On the Earth observation satellite, we are already doing things. We are not just waiting those new satellites, and already some of those that we are using, in particular, I would say Sentinel-3, because we have some radar observation of the northern areas, can be very useful. You might see some from time to time. I'm not speaking about the Arctic, but for example, there has been recently pictures on the Antarctic where you can see ice sheets that are cracking and they will be breaking soon and will create a big problem for the future. But so those new missions will help to improve the knowledge of what we're doing. We have already satellites that are looking into the onto the height of the water, so how this is changing around this area. But I think that some of what we are providing is already used, for example, by the marine services. So already they are generating products that could help already in those areas. I don't know if Pierre, you can say something about that.
Well, yes, this is the European Space Week, and I agree that if we are too close to the satellite, then we could lose the fact that we need to have the good system, we need good science, we need observations, we need experts, etc. And the Copernicus is typically about gathering everything. What we do at the Marine Service is that we are running models when we can get this information from the satellite, transform this with the in-situ observations into something which is assessment every year of the Arctic environment or the global environment in the Earth for the marine, but typically for the Arctic. So we are assessing this. We have hundreds of experts in Europe that are working every year to release this annual report, and this is then transformed into something which is 30 or 60 pages of expert information, plus executive summary for policymakers. You can find it on the website of Copernicus Marine Service. And then we say what we know about this. And this is with this kind of system that we will use in the coming years, all the information that is made available from observations and to assess the situations. So this is not only about satellite, the information we need if we want to understand. This is not only taking a picture and say, well, this is the situation today, this is understand what is going on, and for this we need to work all together. Your question about international cooperation, in 10 seconds, what is done at the scientific level is excellent. And we are transforming this way of working all together at a scientific level into a service value in Copernicus, which I think is exemplary.
Yeah, I just want to add very briefly, I repeat, the GRC study on Arctic, but not only on Arctic, showed that Earth observation is quite remarkable. So the data and the information and everything what is used is very useful. And I give an example. So the president of the commission just announced 2 days ago, she anticipated the Green Deal that she wants to issue in the first 100 days. And one chapter of this is the cost of inaction. What happens if you don't act, if you don't do anything? And there, I can tell you that our scientists in GRC, they did a lot of research and a lot of data, and it's the so-called program which is called PESETA, and there are some clear areas where you can see what is happening in 20, 30, 40, 50 years if you don't do anything. And I'm speaking about droughts, I'm speaking about floods, I'm speaking about heat waves and forest fire. This data is already used and is very useful. Yeah?
Okay, thank you. Any other questions from the audience? There was one.
Hi, this is Pablo Ruiz from Deep Blue Globe. Thank you for the very interesting panel session. I have a question for Mauro in particular. So I am very grateful for the implementation of the Copernicus program in the last 10 years. I think it is a huge European success, so I would like to congratulate you about this. But I have a question regarding the support of the Commission itself or the EU in general toward the developing business. So we have seen that even though Copernicus is a space program, it's more a societal it's a program for society, and there is a lot of focus on the benefits for the society, and there is a lot of focus on the business that could lead in Europe. So my question is, right now at this moment, so we have been supported by this Galileo Masters and Copernicus Masters competition. We have received some initial funding. We have been able to prototype a technology to perform maritime route optimization, thanks to the top quality data from Mercator Ocean and the Copernicus Marine Service. So there is the need for this kind of service. We have seen that this is also a key enabler for maritime autonomous navigation, which is also a priority we have seen here, but it was also mentioned by Carlo De Dorida yesterday from GSA. So now we need to demonstrate this technology, and this is something that has been also mentioned during other sessions, that there is in Europe a gap to demonstrate this project. So for sure, now we can do some trials, but nobody with a ship that could cost millions of euros, they don't want to be the first one that would test this technology. Which are the plans from the Commission to enable these processes and to help the European industry? Thank you.
So thank you very much. It's an excellent question, because I think I'm the first to agree that just producing petabytes or whatever amount of data is not sufficient, so we can be proud of that, but I think we have to do something out of that. When we convinced I would say our policymakers to invest in Copernicus, we had to demonstrate, we have what we call internal and impact assessment. We had to demonstrate that there was environmental, societal, and economic benefits. I think there's no doubt about the environmental and societal. I think it has been demonstrated all along these days. For the economic benefits, we have some economic studies in that respect, so they are also available on our website. But concretely, I think that what's happening here in Helsinki is just showing something that we can do. It's some help that we can do in order to take up what we are doing and to create new businesses. I have a lot of respect and sympathy for all of you that you're starting new businesses based on that. Our commitment is really to try to be as sustainable as possible in the future, not to stop the flow of the data, because we don't want that you start, for example, investing in some ideas, and once they are active, we suddenly finish the flow, and actually all intellectual and financial investment is lost. So it's very important that at the same time, we would like really to interact with you in order to improve these aspects. In the evolution of the new regulation, we will partner more and more, for example, with the GSA, now it's called USPA, also for the business uptake of Copernicus. And the main reason for that is because we think that there are a lot of synergies and potentialities of working together between navigation and Earth observation. And you have also seen, if you participated to the master yesterday, there are already prizes for those proposals that are joining the two capacities, and maybe in the future also something about navigation. There is one point, if I can, I think we have also to start to inform new generations about that. So Copernicus, I mean, speaking for that, is not a policy, it's a tool. It's a tool not for space geeks, but it's a tool for those working in several different areas. And I think it would be very important already to introduce in plans of studies in university, high schools, and so on, these new technologies that are not just for space people. They can be for agronomists, they can be for people working in the marine domain, they can be for people working in raw materials, and so on. This might create a new knowledge of that and also create new ideas. So that, yes, we will try to actually to support more and more this movement from ideas to something that is concrete and business-oriented.
If I can.
Yeah.
Just a few figures just to complement. Just to explain to you that in Copernicus, what we have companies involved in the supply chain. Typically in the marine service with Mercator, we have 300 entities that are working with us for developing the information. Then this information is made available open and freely, and then we have thousands of users. In these thousands, we have 3,000 business companies. They are downloading 50% of the information. So this is really efficient, this uptake instrument that we are implementing.
Okay, thanks. Just one additional, very concrete example. So Copernicus provides huge data, so which is very difficult to process. And this is one of the issues that small companies especially, they mention, say, look, we don't have this processing power. And in fact, DG Grow, and Mauro is very much aware, so they created this interface, which is called DIAS, is Data Information Access System, that in fact is taking the burden of processing from the companies to this interface that is managed by another entity, and in such a way that the small companies, that they should think only to how to use this information that is already processed in such a way that can create the best application and services. So this is a kind of facilitation that European Commission did for the companies.
Okay, thank you. We have 2 more minutes, so if we had a question still from the audience, there was one more, yeah.
Thank you very much. Hello, my name is Juho Rantonen. I am one of the people of this new generation that you just spoke about. Thank you, Mauro, and thank you to all panelists for the interesting discussion. My question to you is about these new generations using this information that you have to give. What kind of actions are you taking at the moment? What can be done and what should be done in order to give this new generation this new knowledge? And also, as you, Mauro, mentioned before, these Arctic peoples, these locals living in the Arctic Circle, how to cooperate with these people more and ask how they want their land to be used. Thank you.
Any quick response to that?
Yes, I think that very quickly. When we had the midterm review of Copernicus, I think everyone was very happy about that, but there were 2 points that were raised. First, to increase the knowledge, and second, to increase the marketability of that. And this is more or less what you're asking. So we have to, for sure, to disseminate more. We should not preach to the convinced, but I think we have to convert the other. So and you can convert people if they learn what they're doing. So we really need to explain more and more, and we will invest even more and more. But I can tell you, if we spoke about, in my entourage, I spoke 5 years ago about Copernicus, I was very disappointed because people were telling me, you're speaking about Galileo. I said, no, Copernicus is something different. Now, if I speak about Copernicus, people start to understand what I'm speaking about. So I'm quite happy about that, at least there is some knowledge about that. And then the second point, if we have really to support the markets, because again, I know very well your difficulty. I'm not an entrepreneur, but I deal with many of you, and I, again, have very much respect. And more I see what you're doing, the more I think that there is a need to support you from the knowledge in the beginning, but also all along the life of your project, because what you're doing is excellent for you, but is excellent for everyone.
Okay, thank you.
Just one small thing I can add here. So, to create awareness is a permanent scope, yeah? To create more awareness, because indeed, people do not know what means Galileo, Copernicus. They don't even know that the European Union has a constellation of satellites, yeah? But this is something that also need to be taken also by the politicians, and it's something that we are pushing all the time. But what I would like to mention at the level of the scientists, I think that things are going relatively well. For example, we are doing every year a summer school for navigation for GNSS, and the last time we did in Ispra and went very well. So the awareness between the scientists is extremely high, and what I want to tell you, a lot of young people were present to these schools, and they were very interested. Students, PhD people, I think that this is something very important. Also, we are doing some open days in our research center when people can come and we explain them what we do, and we try to make a link, direct link between the research, which is not so easy to explain, and what is the impact on the citizens, on the life of them. So it's an ongoing process, and it's never enough. It's never enough.
Okay. Short comment, I hope.
Yeah. You register, you can download everything. This is open and free, and you can dialogue with the service desk, copernicus.marine.eu. You participate to workshop. There was one 2 weeks ago in Helsinki. There will be five workshop training and user workshop for Wikio, which is the DIAS platform, but also for the Marine Service. And third option, you talk directly to us. We are here, and there is Laurence and Alain just there.
Thank you very much. So dissemination, awareness raising towards sustainability on all levels, also for the Arctic. A warm thank you to our excellent panelists and also for our audience for the questions. This concludes this panel. Thank you.
Thank you, panelists. Thank you so much for that great moderation, Heidi. Well, we've come to the end, or almost the end, of the European Space Week here in Helsinki. Ladies and gentlemen, this might be a very good time to thank our wonderful Finnish hosts for putting on what has been the best Space Week ever. What do you think? What do you think? Like for the Olympics, it's always the best week ever, every time we have it. And this is definitely the case for this one. Ladies and gentlemen, I give the final word to a representative of the Ministry of Economic Affairs. He is the Undersecretary of State, Mr. Petri Peltonen. Tervetuloa.
Thank you, Andre. Ladies and gentlemen, dear space people, let me first of all start with a word from our Minister of Economic Affairs, Katri Kulmuni. She unfortunately could not make it to the closing session, and I'm sure at least all the Finns know very well the reasons. We've had just about the historically turbulent week in our political system, and she, as the party leader of her political party, obviously she has had to rearrange all her activities of this week, including the Space Week. But I do have the pleasure of giving her speech here. So, dear space people, I am delighted to give the closing remarks on behalf of Minister Katri Kulmuni of these highly interesting 3 days. We are very proud that Finland has had the opportunity to host the Space Week, and we wish to thank the European Commission for the successful organization and good collaboration. I also thank all the speakers and moderators for your valuable time and expertise in making this event successful. European Space Week is part of the Finnish presidency of the European Union. I am happy to see that the topics important to us have been enthusiastically discussed here as well. Sustainable space, sustainable Europe, sustainable future was the overall theme of this year's European Space Week. In accordance with the Finnish presidency program, Sustainable Europe Towards Sustainable Future. One of the main priorities of Finland's presidency was to foster the European leadership in tackling climate change. The EU is striving for transformation to a climate-neutral economy. As our first panel concluded, space infrastructure and data plays a key role, in particular by providing tools for monitoring changes in the environment. I am certain that we can all agree to the message by Thomas Lechange: we must do our utmost to save the planet for future generations. Last Friday, the Competitiveness Council discussed the role of space as one of the enablers contributing to sustainable growth. The second panel yesterday, taking into account in particular the opportunities provided by the new space economy, continued the discussion. It can be concluded that the renewal and development of the European space industry is essential for its competitiveness. We must also foster the space industry linkages to other sectors of renewable and growth, in particular in digital transformation and climate action. We must ensure that space activities are carried out in a sustainable and responsible manner. Space debris is one of the most serious risks to the sustainability of space activities. Thus, the third panel concluded that it's essential for Europe to be among the leaders in promoting international principles, responsible behavior in outer space. Crowding orbits are not only a challenge, but also an opportunity for creating a new market for new solutions, such as on-orbit servicing and active debris removal. It is of utmost importance that European space sector is placed at the forefront of this market. I'm also glad that the Arctic policy is among the priorities of the Finnish presidency. Last Friday, the Competitiveness Council approved the Council conclusions on space solutions for sustainable Arctic. These conclusions are well in line with today's panel that stress that the space can act as the true enabler for Arctic, ensuring economically, socially, and environmentally sustainable growth in the area. It is important that this work and discussion is continued with the evolving Arctic policy of the European Union. For success of European space, I have to stress the importance of the good collaboration between European partners, in particular the European Union and the European Space Agency. This event shows success stories of European organizations, and we have many successes to come. Ladies and gentlemen, last week the ministers of the member states of the European Space Agency gathered in Seville, Spain, to decide on the future programs and priorities of the agency, after which the member states met in Brussels in the Competitiveness Council. In both occasions, it was stressed in several contributions that only together we can succeed in the global competition. We have to work towards common European goals, towards common European strategy. I wish to conclude my speech with a few words about the Finnish space activities. The priorities in space policy during the Finnish presidency: space for climate action and sustainable development, space for renewal and growth, and for Arctic needs, as well as sustainable use of space, are also those core elements of our national space strategy. Finland is a young spacefaring nation, even though it has been active in space research and technology as well as international space collaboration for decades already. The first Finnish satellite was launched to the orbit only in 2017. Currently, there are 7 Finnish satellites on orbit. Finland is very committed to support the development and renewal of its space sector. There are several actions ongoing as regards to this, including new space economy program by Business Finland, revised national space strategy, newly established space legislation, and the recent restructuring of the space administration in Finland. We support these objectives also in the European collaboration and hope to foster this through our recently increased funding for the European Space Agency and through our EU space programs. Ladies and gentlemen, finally, I wish to thank our space teams at my ministry, Business Finland and VTT, and our Finnish partners, the Ministry of Transport and Communication, the Finnish Meteorological Institute, and all the others who have worked with in order to create this successful event. And of course, the most deserved thanks go to the European Commission and to the European Space Agency. Ladies and gentlemen, this event has shown that space is truly a driver for sustainable growth and renewal. Through European collaboration, we can ensure our successful future also in the coming days. Thank you very much.
Thank you, Petri Peltonen, and please give our warmest regards to Madam Minister and all the best of luck for the changes to come. Ladies and gentlemen, I think the best possible way to close this wonderful Space Week would be to wish all of our Finnish colleagues a very, very happy Independence Day tomorrow, to all of you. And to all of the rest of you, have a safe journey home, and let's keep space at the top of the agenda. Thank you so much. Merci.